JavaScript's everywhere, and there's no better and more elegant way to write JavaScript than using TypeScript. Well, this is me, and my name is Manik, and I've been a full-stack developer developing applications of all scales since 2010. Programming is my passion, and I code day in and out every day. I eat and breathe code and love to learn new technologies and teach the ones that I'm well versed with. I started working on TypeScript back in 2016 and had to struggle my way to learn TypeScript. I started by taking some courses which did not teach me the details of the language. Then I went through a couple of books, and by building a handful of applications and a lot of Stack Overflow, I could pave my way through learning TypeScript. After working for 7 odd years on TypeScript, I thought my journey could have been easier had there been a course that could have taught me the details of the language. I searched on the marketplace and tried to hunt for such a course, and to my surprise, even the best-selling and the highest-rated courses lacked the details. Some courses don't touch on the theoretical knowledge needed to grasp TypeScript, while others don't teach the practical implementation along with other technologies like React and Node. This is important because while developing a project, in most of the cases, you would not be using TypeScript in isolation. That's when I decided to come up with a course and structure it in such a way so that my students do not have to go through the steep learning curve that I did. Once you're through with the theoretical part of TypeScript and you understand the intrinsics of the language, we set off to build a full stack application. We build a task management application where you create a new task, set the priority, and set the status of the task as well. We also build a real-time task counter and work on the complete server state synchronization. While building the front end of this application, you learn how to use TypeScript with React Material UI, React Query, and Context API. And when building the REST API with NodeJS as the backend service for the application, we get practical hands-on experience on how to use TypeScript in conjunction with NodeJS, Express, TypeORM, and MySQL. If you're a full-stack developer, you can enjoy and build a complete project with me. And if your skill sets are limited to backend or frontend, you can choose the module based on your skills, and these modules are self-contained and do not have dependency on each other. This is a very practical course with lots of practice and quizzes. I'm always available to answer your questions in QA section for each lecture. Once again, welcome to this course, and in this video, we're going to have a broad overview of what we're going to learn in each of the sections of this course. I myself started learning TypeScript in 2016 and have been working on TypeScript since then, and have taken a lot of courses on the marketplace, even the best-selling ones as well as top-rated ones. There wasn't one course that taught me about TypeScript and how to use it along with other technologies. So I took multiple courses, went through a few books, a lot of TypeScript programming and Stack Overflow, and that's how I kind of paved my way and learned to use TypeScript with these technologies. So while designing the curriculum of this course, I kept in mind that my students don't struggle to learn TypeScript and how it is used with other technologies the way I did, and they are able to learn TypeScript and adapt it along with other technologies at a much faster pace. So let's go through the curriculum and understand what we are going to learn throughout this course. First, we will learn what are types and different types of types in TypeScript. TypeScript has primitive types, object types, array types, and we would go into details of all these types. We would also learn what is type inference and how TypeScript interprets your code, and then jump into some advanced types as well. So the first module of the course is an introduction to types and what TypeScript is and how you use types within your code. Moving on, in the second module, we'll learn about functions in TypeScript. We will see how we can declare functions, what are default and optional parameters and how we can pass them to functions, and how we can create custom parameters for our functions and strictly type them, and then jumping into custom returns and call signatures. These terms might not make sense to you as of now, but this is just an overview of what functions in TypeScript are, and each of these modules contain all the detailed videos and the information and knowledge that you require. Then there is something known as generics in TypeScript. Generics help us write polymorphic functions. So we will understand what are polymorphic functions and how they help us, what are the problems with function overloads, and then we get into an introduction to generics. Once we know what are generics, we will learn how to work with generics, and there are a lot of practice exercises as well so that you are able to practice the implementation of generics in your code. Once we are accustomed with generics, we will move on to classes and inheritance. TypeScript offers a wide array of features which help you write object-oriented code. And we will learn all about classes and its instances and constructor functions in this module of the course. We will understand the features of various members of the class, and we'll also deep dive into inheritance, followed by access modifiers. And then in the end, we're going to talk about accessors and mutators. We'll understand what are accessors and mutators, and we'll write a couple of them as well. This module is going to give you a very strong foundation of object-oriented programming and an introduction to core features TypeScript has to offer, which help you write object-oriented code. Once we are well versed with classes and inheritance, we're going to move on to abstract classes and interfaces. We'll understand what are static properties and abstract classes. We'll also deep dive into abstract classes and understand the difference between abstract classes and normal classes. Here we're going to talk about a very important topic, that is interfaces. We're going to have lots of practice exercises about interfaces, and then we're going to talk about multiple inheritance as well. Finally, we're going to understand how generics can be used with interfaces. So this section of the course is all about abstract classes and interfaces. In the next section of the course, we'll understand what is a TypeScript compiler and how we can tweak the TypeScript compiler to our needs. We'll look at various file options offered by the TypeScript compiler, and then we'll look at various type checking options that the TypeScript compiler has to offer. Finally, we'll write a few NPM scripts and understand what are source maps and how file watcher works along with the TypeScript compiler. So this section is all about TypeScript compiler and how you can use TypeScript compiler during development and to emit production-ready code. After the TypeScript compiler, we're going to talk about a JavaScript topic that confuses a lot of developers. And that topic is about prototypes and objects. It is very important to understand prototypes and objects and prototypical inheritance, as we would be using that in the next section of the course, which talks about decorators. So we will understand this keyword in JavaScript, followed by constructor functions and prototypes. And then we are going to understand what is prototypical inheritance and how is it different from classical class-based inheritance. Then I'm going to introduce you to a new topic which is called property descriptors, and we'll understand how property descriptors work with prototypical inheritance. Finally, we are going to understand how classes in JavaScript are just a syntactic sugar over prototypes, and how classes use prototypes behind the scenes. This is a very in detail and in-depth module in this course, and this will help you set up a very strong foundation for JavaScript itself and help you in writing better JavaScript code, as well as contributing to TypeScript, because these features of JavaScript are used in TypeScript as well. Once we are well versed with prototypes, we are going to move on to decorators. Decorators are an experimental feature in TypeScript, but decorators are used widely across a lot of TypeScript applications. Libraries such as Angular make a wide use of decorators. So we'll learn everything about decorators and how they work. And then we're going to move on to something known as decorator factories. Once we understand decorator factories, we're going to talk about decorators that are applied to various members of the class. And then there are certain advanced topics such as modifying the prototypes, multiple decorators, and decorator execution sequence that we're going to talk about in this section of the course. So Module 8, everything about decorators. Then we're going to move on to a lot of advanced concepts in TypeScript. I'm just listing a few advanced concepts over here, but in the module, we are going to talk about a lot more concepts. So a few examples of advanced concepts that we're going to talk about and understand them is type widening, discriminated unions, subtypes and supertypes, typecasting, totality, conditional types, and so on. These are the topics a lot of courses don't touch upon, but I'm going to talk about all these advanced features of TypeScript in detail. Moving on, we're going to start building our app. So our module 10, 11, and 12 are dedicated to building a full stack app. In module 10, 11, and 12 respectively, we are going to work on the front end, the back end, as well as the front end and back end integration. So this is a full stack app that we're going to create. What is different about building this particular full stack app as compared to any other course on the marketplace is that we're going to build an application with the technologies that you're primarily used to using and see how TypeScript works in conjunction with these existing technologies. It's not just about teaching you the syntax of TypeScript, it's about how you can use TypeScript in your day-to-day programming with these technologies that you're already used to using. So if you're a front-end developer, you will learn how you can use TypeScript with React as well as with Material UI. Now, if you're a Node or a back-end developer, we are going to develop an entire API on Node.js. And you will learn how you can use TypeScript with Node.js, TypeORM, and MySQL. And finally, we are also going to see in the last section how we can use TypeScript along with React Query and Context API. So if you are a full stack developer, you can work on all these 3 modules along with me, and all resources are included for each of these lectures. And if you're a front-end developer, you can take the first and the last section. And if you're just a back-end developer or a Node.js developer, you can take the 11th module of this course. So considering your own skill set, you can choose the module that you want to take up. I have tried to build a course which is very practical, has a lot of quiz questions and practice sessions, and teaches you TypeScript and how to use TypeScript in conjunction with other technologies as well. So not just restricting you to teaching the syntax of TypeScript, but how you can implement and use TypeScript in your existing applications and enhance your career as a software developer. I hope you like this course. See you in the next video. Let's have a demonstration of what we would be building. We would be building this personal task management application. So this application over here has a form for creating new tasks, and this is the area where all the tasks are displayed. There are 3 counters as well, which give you the count of tasks. So the count of tasks that are in to-do state, the count of tasks that are in progress state, and the count of tasks that are completed. We can use this switch to set a task to in progress or not. So if I set this task to in progress, the counters are updated simultaneously as well. This is not just a React frontend. We are also going to build a complete Node API with API endpoints that does the task management for us. Before I show you the database, as a proof of this app being connected to the Node API that we have created, let's try to create a new task. So let's call this task as new test task. Let's copy and paste some lorem ipsum text. And let's set the priority of this task to high. And let's create this task. You will see the moment you create this task, a success message appears. And this success message is going to vanish after 7 seconds. There you go. And the new task is created and is updated to our task list. Now I can click on any of these tasks and mark it as complete as well, and that task would vanish from the task list. And all these counters are in sync with the real state of our database. So if we have total 7 tasks over here with none of the tasks in progress, that's what our database would also show. So let's go to our database. I use DataGrip in order to manage the database. So let's refresh our database. You will see our database also has 7 tasks and none of the task is in progress state. There are total 5 tasks that have been completed and 2 tasks are in to do. Let's go to our browser and that's what our counters state as well. Let's try putting this task in progress and let's go back to our database. Let's refresh it. Now one of the tasks is in progress, 1 is in to do and 5 are completed, and that's what the counter states. So all this is being managed through a Node API, and that's what we are going to build in this particular course. So we're going to build this full stack app that has the React frontend. It has a Node API server, and then we're going to integrate the Node API server with the frontend React app. Also, till now, I have been using WebStorm as my editor. And since most of the people are accustomed with using VS Code, For developing the entire project, I'm going to use VS Code. I'm doing so that it gives you a feel of using TypeScript within VS Code as well. So if you use WebStorm, you already know how TypeScript behaves in WebStorm. And if you use VS Code in this entire project, I'm going to use VS Code and you get the feel of how TypeScript behaves in VS Code. I'm super excited about this and see you in the next video. Before we start learning TypeScript, let's have a look at what TypeScript is. Here we are on TypeScript website and this is what it says. TypeScript is JavaScript with syntax for types. That's the simplest possible definition for TypeScript, but it does much more than that. TypeScript is a strongly typed programming language that builds upon JavaScript, giving you better tooling at any scale. That's what kind of explains TypeScript in detail. So let's understand what TypeScript is and how it delivers what it promises. Here's a quick flow that lets you understand what TypeScript is. TypeScript as a programming language is like a kind of superset to JavaScript. So when you as a programmer are writing your JavaScript apps using TypeScript, TypeScript gives you these extra features that JavaScript doesn't have by default. So you as a programmer get access to features like strict types, editor checks, auto-completion, generics, object-oriented features, decorators, and so on. This helps you write better and scalable JavaScript apps using TypeScript and use patterns that are unavailable to you in vanilla JavaScript. In the end, all the code that you write in TypeScript is compiled to vanilla JavaScript using the TypeScript compiler. So TypeScript in a nutshell is giving you features to write strictly typed, scalable JavaScript apps. The obvious reason why you would want to use TypeScript is the features it offers that JavaScript doesn't. We would be learning all these features offered by TypeScript throughout this course. With this understanding of TypeScript, let's move on to the following lecture, where we would start installing Node.js and TypeScript to start working with it. So see you in the next one. In order to work with TypeScript, we would need to have Node.js and NPM installed on our system. Since you're learning TypeScript, I'm assuming that you're already aware of what NPM is. So if you already have Node and NPM installed on your machine and you're well aware of what Node is and NPM is, you can skip this lecture and move on to the next one. But if you don't have Node installed and you don't know what NPM is, you can just follow along with this video. So as I said, in order to work with TypeScript, we need to install Node.js on our machine. We need to install Node.js because Node.js includes NPM, which stands for Node Package Manager, which helps us to manage dependencies for our project in TypeScript. Also, later during the course, we build a Node.js backend API, which does require you to have Node.js installed on your machine. Now, as I said, NPM stands for Node Package Manager, and it lets you install various NPM packages on your computer. In order to install Node and NPM, we can navigate to this Node.js website, which is nodejs.org. And based on your operating system, you can download the LTS version. As of recording of the course, the LTS version is 16.17.0. So if you click on the link over here, it's going to prompt you to download and you can save the download on your machine. If you're on Windows, make sure you're downloading for Windows, and same goes for Linux as well. And to install Node and NPM, all you need to do is download the installer, run the installer, and both NPM and Node.js would be installed on your system. I already have Node installed on my system, so I will not install it again. But once you have run the installer, you can check whether Node.js is installed on your system or not by going to your terminal and running a command. On Mac OS, you can use the default terminal. Linux also has a default terminal integrated into it. For Windows, you can use Windows Subsystem for Linux or the default command prompt based on your choice. And within your terminal, you can run this command, which is node-version, and it'll show you the version of Node.js that's installed on your machine. To check whether NPM was installed or not, you can run the same command for NPM as well. So it shows that NPM 8.3.1 is installed on my computer. I'm using a Mac and my terminal is iTerm. That's just for the people who are curious about the user interface of my terminal. If your system successfully shows a version like this, then it means both Node and NPM have been successfully installed on your system. Since we now have Node.js and NPM installed, we can move ahead to the next video. See you in the next one. Welcome back, guys. So in the last video, we had a look at the advantages of using TypeScript or a strictly typed language. And in this video, we're going to set up our code editor and we are going to install TypeScript and set up the development environment for ourselves so that we are on the same page. The first thing that we're going to need is a code editor, and you do have a few choices here. The first option is the Visual Studio Code. Now, this is the preferred code editor for most of the people developing in JavaScript or using TypeScript, and many people are familiar with this particular code editor. So you can definitely go ahead and use Visual Studio Code for the entire course. The second option that you have is WebStorm. Now, this is not free but is paid and is my preferred choice of IDE. I'm pretty used to using WebStorm, and that's what I use when I code on day-to-day basis, and this is what I'm going to use throughout this entire course. Now, let me just point out over here that anything that I do in the course is not specific to the IDE that you use. So whether you're using WebStorm or you're using Visual Studio Code, it doesn't really matter. So whatever code that I'm going to write or the settings that I'm going to do in my IDE are applicable to both Visual Studio Code and WebStorm. So I'm not going to use any specific IDE features here, but general TypeScript features. So again, I'm going to use WebStorm, and you're free to use any IDE that you want to. Now, the next step is to install TypeScript on our system. We're going to navigate to the download TypeScript page on the TypeScript website, and you can see that they have listed various ways in which you can install TypeScript. The first method of installing TypeScript is specific to your particular project. So you don't need to install TypeScript globally on your system, and you can install it as an NPM dependency just for the project that you're working on. And in that case, you would have to use npx tsc command in order to compile your TypeScript files. But just to keep things simple, I'm going to go ahead with the global install and not make it specific to our project. In case of a global install, we can install TypeScript globally on our system, and then instead of using npx, we can directly use the tsc command in order to compile our TypeScript files. So let's just go ahead and get TypeScript installed on our system. And for that, I'm going to copy this command. Now I'm going to go back to my IDE, and WebStorm, just like the Visual Studio Code, has a built-in terminal, and I'm going to open that. I have created a TypeScript directory on my system, and my terminal is navigated into that particular TypeScript directory as well. So here, I'm going to pass in this npm global command to install TypeScript globally on my system, and let's just go ahead and do it. Now TypeScript is installed globally on my system, and we can check it through this command. Now you see it tells me that version 4.5.2 is installed on my system as per the latest version while I'm recording this video. Now, since TypeScript is installed on our system, the last thing that we want to do within this TypeScript directory is instantiate a TypeScript configuration file. Now, there's a simple command to do that. So what you need to do is tsc --init. Now, when I run this command, it will generate a TypeScript config file on my system and within the TypeScript directory, which is going to be specific to this particular directory. Now, if you see, we have got this tsconfig file here. I'm just going to open this file and show you the contents of this file. Now you see it has got various settings and it comes with certain default settings for TypeScript. We are going to go through these settings and most important ones as we progress through the course. But for right now, just for the sake of simplicity, we are going to stick to the default settings that TypeScript creates as the tsconfig.json file within our directory. So that's pretty much it. We have TypeScript installed. We have the tsconfig.json file within our TypeScript directory, and we can start writing some TypeScript. I'm going to see you in the next video. Welcome back, guys. So in our previous video, we installed our IDE and installed TypeScript on our system. And now we are ready to write some TypeScript code. We already know that TypeScript helps us write better code by using strict typing and various OOP features or object-oriented programming features that are not provided by JavaScript by default. But what do we mean by strict typing? What does it actually look like? So here we are going to write our first TypeScript program and understand what strict typing actually means. I'm going to start by creating a few files within our project, and the first file that I'm going to create is an index.html file. So once we have our index.html file created within our project, next thing we're going to do is create an index.js file, and we are going to start by writing a simple JavaScript program and gradually convert that to a TypeScript program. So let's create a JavaScript file as well. We have our index.html and we have index.javascript. In our index.html file, I'm going to write some boilerplate HTML code. So this is simple HTML document. Now I'm going to attach my index.js file to my index.html file. Now my index.js file is attached to my index.html file, and I'm going to go to my index.js file and I'm going to write a simple program. I'm going to write a function that takes in two numbers and adds them as a sum. Pretty trivial. So now my function takes in two parameters, a and b, and we're going to add these two. So this is a simple function that we have written in JavaScript. Now let's just simply execute the sum function and pass in certain arguments as a and b and see if it logs the sum to our console. So here I'm trying to add 2 and 3, log the value of the sum to the console. This a and b here are not typed by me. This is actually my IDE suggesting that my sum function needs two parameters, a and b. So don't get confused by this particular syntax. The thing that you see in white is suggested by my IDE. So it's not a JavaScript feature that we are using. It's just my IDE suggesting me that you need to pass in two parameters or two arguments, to this particular function. You're going to see this throughout the course, so don't be paranoid by this. So let's go to our browser and see if you're able to log the sum of 2 and 3 to our console. So you see we get 5 here. So what is the problem with this code? How TypeScript helps us to prevent errors in this code? Now let me explain that with an example. What if you're working in a team and someone tries to do something like this to this function? So instead of passing in numbers, someone tries to pass in strings. Now let's jump to our console and see if we get the same result that we expect. The answer is no. So instead of calculating the sum for 2 and 3, we end up concatenating 2 and 3. This is not what we expected. This is where TypeScript can help us. Now this problem might seem to be very hypothetical right now, and you may say that why someone would do this. But the thing is that as your application grows and you use more complex structures within your application, scenarios like this will emerge and they will be pretty common. And we will talk about those complicated cases and scenarios and walk through all of them within this course. But for now, let's see how TypeScript can help us avoid these kind of errors, or in particular, error within this function. And for that, I'm going to open my terminal and I'm going to create a new TypeScript file. Now we have our first TypeScript file created within our project, and this file is empty as of now. Now what I'm going to do is I'm going to go to my index.js file. I'm going to copy all my code from the JavaScript file and paste it within the TypeScript file. And I'm just going to delete this JavaScript file over here. So with that out of the way, you already see that my IDE is shouting at me over here and giving me errors for A and B. Now it's saying that parameter A has implicitly typed of type any. Now we are going to understand types in more detail as we progress through the course. Now I'm going to refactor this code right now to comply to TypeScript standards, and will explain you in a moment what I'm trying to do over here. Let me first remove this console log. And here I'm going to refactor our function. This is a TypeScript function. What have I done over here? I'm explicitly telling TypeScript that any argument passed to this particular sum function of type A should be of type number and number only. So you cannot pass in any argument which is of type string. And for B as well, I'm expecting a number. So my sum function now accepts two arguments, and both of them would be of type number. The third thing that we need to look over here is that my function itself will return something which is a number itself. So whenever you have this kind of a notation following the parentheses of your function, it states what kind of value your function is going to return. Now this entire course is about assigning types to variables, functions, objects, and arrays, and so on. But this is the minimum syntax that I can show you right now to show you the advantage of TypeScript. Now I'm going to do a console log once again. And since our TypeScript file is now ready, I'm going to compile this TypeScript file into JavaScript. As we have already understood that TypeScript is not understood by your browser, the browser just understands JavaScript. So we have to compile this TypeScript file into JavaScript. Let's do that. I'm going to open my terminal, and in order to compile this TypeScript file to JavaScript, we have to pass a command tscindex.ts. Now what this does is it goes through the entire TypeScript and checks whether the code that you have written is TypeScript compliant or not. And then once it checks that the code is TypeScript compliant, it generates a JavaScript file just besides the TypeScript file that you tried to compile. So if we look in our project directory, we now have an index.js file along with the index.typescript file. Now I can go back to my browser and refresh it to see if these changes are effected there. You see, we get 5. And this is the result that we expected. Now this is all good and was working in JavaScript as well. And we are going to see what happens if we try to pass incorrect values to this function, or pass strings as we did in our previous example to this function, and how TypeScript helps us to catch those errors. And we are going to do this in our next video. Now in the previous video, we wrote this simple sum function in TypeScript, which takes in 2 arguments and adds those 2 numbers and logs them to the console. Now what I'm going to do is I'm going to pass in 2 strings instead of 2 numbers, and then let's see what TypeScript does. So I have converted 2 and 3 into strings instead of numbers, and TypeScript is already throwing, my IDE is already throwing an error. Let's see what that error is. It says argument of type string is not assignable to parameter of type number. So pretty clear. So this shows you that how TypeScript will not allow you to pass in strings to this particular sum function. So even before it compiles your function into JavaScript or your file into JavaScript, it tells you that this is not correct. And this is how it helps you write better code. So you would not be able to pass in string to a function wherein a function actually expects numbers. Now, this is the first way of looking at errors in TypeScript, and that is within your IDE itself. And this is the most prominent and most used way as well. So most of the times we would be writing our code and our IDE would be throwing in errors at us in case we have done something wrong. So the flow with working with TypeScript is pretty smooth because as in when you write code, you get those suggestions within your IDE and you pretty much come to know where you've gone wrong. Now let's look at another place where you can get these kind of errors. Now here I'm going to try to compile this file and let's see what we get. You see, when I try to compile this file, I get an error, and the same error that was being printed by my IDE as well. Now it gives you certain details about the error as well, and it tells you that the argument of type string is not assignable to a parameter of type number. So the function is expecting an argument that should be a number, but we are passing in a string. If you have a look over here, it actually did compile our index.js file. Now, this is something very important that you need to understand. Despite of errors, the TypeScript default behavior is to compile your TypeScript files to JavaScript files. So it does log errors to the terminal, but it still goes ahead and compiles your TypeScript file into a JavaScript file. Now, this default behavior of TypeScript can be overridden as well. Now, to check whether we can override this particular functionality or not, let me just remove the index.js file that we already have within our project. So I have removed the index.js file here. Now the first method where we can instruct TypeScript to not to emit the JavaScript file in case there is an error is by using the no emit on error flag while we are trying to compile our TypeScript into a JavaScript file. Let's have a look at that command. Now you see we are using this no emit on error flag while trying to convert the index.ts file using the tsc command. Now when I use this command, TypeScript will parse through the entire index.ts file and it will check for errors, and just in case it finds any errors, it is not going to compile the index.ts file into JavaScript file. Let's see. Now you see it found the error that we expected it to find, and it has not gone ahead and converted the index.js file. Now we can do this through the tsconfig.json file. The advantage of doing this through tsconfig.json is that we permanently set it up that our TypeScript code should not be compiled to JavaScript just in case there are any errors in our TypeScript code. Now let's look at the tsconfig.json file. Now, if I scroll down, we have this particular property known as no emit on error. This is the same flag that we passed while we were trying to convert our TypeScript file into JavaScript file. Now, by default, this is set to false. And in order to set this to true, I will just uncomment it. Now, it so happens that if I try to compile index.ts using the tsc command, it will not follow or use the tsconfig.json file. That's the default behavior of the tsc command. This is because you're directly trying to convert just one file, that is index.ts, into JavaScript, and it does not use tsconfig in that case, but uses the defaults that are set by TypeScript. Now we can use the help flag to check if there is any other option that is available that helps us use the tsconfig.json file in order to compile our TypeScript files to JavaScript. Now let's look at the help section. Let me make some space here. So you see this tsc command has got various options attached to it, and one of that is this p flag. Now it says compile the project given the path to its configuration file or to a folder with a tsconfig.json file. So what I can do is that I can use this p flag and pass in the tsconfig.json file, and then it will follow the rules of the tsconfig.json. Let me show you how it is done. So this time what I'm going to do is tsc and pass the p flag, and after that I'm going to give it the path to our tsconfig.json file. Now if we execute our command like this, let me open the index.ts. It is going to parse through this TypeScript file, but it is not going to compile because our TypeScript file has got errors. Let's try it out. You see, it parsed through our TypeScript file and it gave the same error that we were expecting out of it, and it has not gone ahead and converted the index.javascript file. So these are the two primary areas that you would be using in order to find errors within your TypeScript files. In our tsconfig.json file, we would keep the property of no emit on error to true, and that's how we are going to progress throughout our course, so that any of our TypeScript files which have got errors in them, they should not be compiled to JavaScript. Now let me convert back these values to numbers and ensure that our file is compiled correctly. Let's try running the same command once again. Now you see it has compiled without any errors, and if I go back to my directory, I would see that index.javascript has been generated. So now you see how TypeScript helps us to avoid errors. I completely understand that the example right now is pretty trivial and it does not reflect the true power of TypeScript as of now. But as promised, we would look into various other use cases as we progress throughout the course. Now in the next video, we are going to deep dive into index.js file and see how it differs from the JavaScript file that we had written previously, and what has TypeScript added to this index.js file. See you in the next video. In our previous video, we wrote this TypeScript function, which takes in two arguments, two numbers, and adds them up, a simple function. Now, TypeScript generated some JavaScript for us by compiling the TypeScript file and then converting it into this index.js file. Now we're going to deep dive into this index.js file and see what TypeScript has generated for us. So if you see, this is our index.js file. Now, if you look at it, it looks exactly like the JavaScript function that we had written. All this is just vanilla JavaScript. So what do we understand from this? We need to understand that TypeScript is just a transpiler. We infer that TypeScript is available to us during development time, and once the TypeScript is compiled, it is compiled to vanilla JavaScript. At the end, it's just vanilla JavaScript that is understood by your browser or by Node. So TypeScript in the end provides us functionality that is not available to us in JavaScript, and that includes strict typing. As we move further along the course, we would also understand that apart from strict typing, there are certain other set of functionalities that TypeScript provides us to write better object-oriented code. But in the end, it all transpiles to JavaScript itself. Now, in most of the cases, TypeScript will not add additional logic to type checking or your JavaScript files. In some cases, you might see TypeScript generating a lot of JavaScript code in order to implement those features which are not available by default in JavaScript. As we move along the course, we would see different cases as we come across them. Now, one more thing, you can choose the version of JavaScript that you want TypeScript to emit for you. So in your tsconfig file, you can choose the JavaScript version that you want. Right now, we are targeting ES 2016. You can, for example, target ES5 as well if you want a wider compatibility. I would leave this to ES 2016 as we progress through the course. So the key takeaway of this video is that the TypeScript is just a transpiler and is only available during development for you to write better code. It is very important to understand this. In the end, it's just the JavaScript that is understood by Node or by your browser. So everything in TypeScript files gets converted to JavaScript files. I'll see you in the next video. Now, since we've got a little bit of flavor of TypeScript and we understand the advantages that it provides us, we can look at different kinds of types and start writing some code. But before we do that, it so turns out that we can use a better way to compile TypeScript using a bundler. We could have used Webpack, but since we want to keep things simple here and focus on TypeScript, I'm going to use Parcel. Later on during the course, I will also show you how you can work with TypeScript and Node and TypeScript with React as well. But for now, for a couple of next lessons, we are going to use Parcel as our bundler so that we can quickly bundle our TypeScript files and convert them to JavaScript files. This is so that I don't have to go to my terminal and keep running these commands again and again. So let's go ahead and configure Parcel in a step-by-step manner. Now, first of all, I'm going to delete all these files that we have here. We don't need them anymore. Once these files are out of the way, I'm going to open my terminal. And within my TypeScript project itself, I'm going to generate a new npm project. To do that, I'm going to do npm init with a y flag. Now, this y flag basically instantiates the npm project with all defaults added. Now, the moment you run this, you're going to end up with a package.json file. Since this is a TypeScript course, I'm going to assume that you know what package.json is and how npm works. So we are going to manage all our dependencies here within the package.json file. Now, the next thing I want to do is I want to install Parcel as a development dependency within this project so that we can use Parcel in order to bundle our TypeScript files. So let me quickly install Parcel. I'm going to install Parcel as a development dependency. I'll be back once this is done. Now, Parcel is successfully installed within our project, and we do see it as a development dependency within our package.json file as well. Now, within our project folder, I'm going to quickly create an index.html file. Once I have created the index.html file, the next thing that I'm going to do is I'm going to create an src directory for storing all our TypeScript files, and then I'm going to create one index.ts file as well. We have created the src directory. Now I'm going to create an index.ts file within this directory. So we have our index.ts within our src directory. Now, since we have all our files in place, next thing I'm going to do is include my index.ts file in my index.html file. Just adding some boilerplate code here. Once we have this, let's link our index.ts file to our HTML. Now, the good thing about Parcel as a bundler is that it requires minimal setup. So it will automatically detect this index.ts file and replace it with index.javascript file, and it will do the transpiling of TypeScript as well for us. The next thing that I'm going to do is that I'm going to generate a tsconfig.json file. So let's do that. Now, passing this tsc in it generates this tsconfig file for us. Now, within our tsconfig file, I'm again going to navigate to no emit on errors here, and I'm going to uncomment this line because I don't want my JavaScript to be emitted just in case my TypeScript has got any errors. Now, just to keep our TypeScript code clean and organized, we are going to use prettier as well. I'm sure that you're already aware what prettier is, and if you aren't, prettier does what it says and it prettifies all your code without the use of any complex configuration files. Let's quickly go to Prettier docs and look at the installation instructions. I'll navigate to install. And there you have it. Just copy the npm install command, open our terminal, and we're going to run this command. I'll be back once Prettier is installed. Okay, now Prettier is installed on our system, and the last thing that we are going to do in order to make Prettier work is just generate its configuration file, just in case we want to tweak a few things here and there later during the course. Just copy this code which just generates an empty object in .prettierrc.json file and run this in our terminal. And there we see it. We have prettierrc.json file and it has got that empty object in it. With all that done, we're just going to create one npm script so that we are able to run Parcel, and Parcel is able to compile all our TypeScript files and generate the final JavaScript file for us. And this is going to help us during development because Parcel will fire a web server for us as well, and it will watch our files for changes. So the moment we make any change to our TypeScript file, Parcel is going to recompile the file and render the same in the browser. So what I'm going to do is I'm going to create a new npm script here which fires certain Parcel commands, and these Parcel commands will watch our TypeScript files for any changes and will compile the TypeScript into JavaScript and hot reload our browser as well, so that we are easily able to continue with the development and compile our TypeScript files into JavaScript files on the fly. Let's quickly open our terminal and see what all commands are available in Parcel for us to do that. Let me make some space here. So if you see, Parcel has a serve command which starts the development server for us, and it also has the watch command which starts the bundler in the watch mode. So this particular command will watch all our files for any changes and will keep compiling simultaneously whenever we make a change. In order to start the development server as well as watch our files, we would have to run two Parcel commands instead of one. And we can easily do that in npm. So let's get started. I'm going to create a new command here and call that start. Now in the start command, I'm going to pass in two Parcel commands. So the first Parcel command is going to be Parcel serve, which is the default Parcel command. And the second one is going to be Parcel watch, as we just saw in the terminal. So let's start with the Parcel command first. Now this particular command over here is going to start the Parcel server using our index.html file, and we need to pass another command so that Parcel watches our files as well. In order to do that, we have to put this command in brackets, use an and symbol, and then pass the second Parcel command that we want to run simultaneously. Let me convert this to npx as well. Now let's just quickly understand what we are doing here. We are first passing in an npx Parcel with index.html. This runs our development server, and then we are using npx Parcel with index.html with the watch command, and this watch command keeps watching our TypeScript files for any changes, and the moment there is a change, it compiles them into JavaScript files and hot reloads our web server for us. Another thing that you want to do here is that you want to remove this main property from here, because Parcel doesn't play well with this main property and it keeps looking for index.js files. So just that Parcel doesn't throw any error, we have to remove this main property from this particular object. Now let's quickly go to our terminal and see if the start command is running successfully or not. Our TypeScript is compiling successfully. Let's just quickly open this URL in our browser and see how it looks like. We are loading our HTML successfully here. Now just so that we are able to easily view our console and the result of our TypeScript files, now I'm going to right click here and click on Inspect to open the Google Developer Tools. Now I'm going to align the developer tools along with my IDE. So let me just quickly do that. Here's my IDE, and I'm going to align them side by side. Over here in my developer tools, I'm going to open console. So we have our console, our TypeScript is compiling successfully. Now to test if everything is working perfectly, I'm going to open my index.ts file. And in this index.ts file, I'm going to change this test to hello world. Now you see the moment I do that, our console log message also changes. So everything is working perfectly now. So our setup is ready, and now we can move on to the next video where we can start understanding different types in TypeScript. I hope this one was clear. I'll see you in the next one. Thanks for watching. Welcome back, guys. So in this module, we're going to look at what are types and what are different types of types available in TypeScript. So this video is about a brief introduction about types. So let's look at the formal definition of types and try to understand what do we mean by the term type in TypeScript. So a type is a definition that is assigned to a value, and then that defines the things that you can do or you cannot do with that kind of value. Just so that it makes more sense, let's have a look at some examples and try to understand what do we mean by this definition. So here's the first example. Over here, we have a variable called first name, and it has been assigned a type of string. Now, the first name variable would always be a string. Now, this defines what you can do and what you cannot do with the variable first name. So, for example, since the variable first name is of the type string, you can use all string methods on the variable first name. So, for example, here I'm trying to calculate the length of the string or first name using the length method. Now this is possible and TypeScript would not throw an error because TypeScript knows that the first name variable is of the type string and all string methods can be called on the first name variable. Now this defines what you can do with this kind of type. Since first name is defined as a string, it also defines what you cannot do with this kind of a variable. Now you cannot call number methods on the first name variable because it is of the type string. So over here, if I try to calculate the exponential value of first name, TypeScript will throw an error. It will say that you cannot call number methods on a type which is of the type string. So looking at the definition once again, a type is a definition assigned to a value and defines the things that you can do or cannot do with that kind of value. Now here we can look at another example. Let's look at another case where a type defines what you can do with that value. So for example, here I have a constant called sequence, and this sequence constant is of the type of array of numbers. So sequence will always have an array of numbers, right? So I have assigned it a value of array of numbers. Now I can loop through an array of numbers using for each method, and TypeScript will not throw an error because TypeScript knows that sequence is of the type array and array can be looped using for each method. So this is a perfect example of the things you can do with this kind of type. Now let's look at another example. Now here we are looking at a scenario where TypeScript is telling us the things that we cannot do with a particular type. So for example, here I have a variable called user, and this user is of the type of object. So this is an object literal syntax that you use in order to define a variable which contains an object. So this variable user will always be an object, and this object contains these properties. So right now it has a name property, which is mark, the value is mark, and then it has a location property and its value is London. Now if I try to iterate through the user object using the for each method, TypeScript will throw an error because the objects cannot be iterated using the for each method. It's the arrays that can be iterated using for each method. So TypeScript would not let you do something like this and hence end up avoiding errors. So it clearly tells you that you cannot do this kind of an operation with the user object. Now let's look at a hierarchy of available types in TypeScript. So this table is for your reference, and these are the kind of types that we are going to learn throughout this module. So we are going to understand each one of these types in this particular module. Now most of these types are already available in JavaScript and you would be aware of these types, but some of these types aren't, such as enums, tuples, void. So we would go through all of these types in this particular module and try to understand what each of these types means and how you can use them in TypeScript. So that's all for the basic introduction of types. I'll see you in the next video. Thanks for watching. So welcome back people. In this video, we are going to look at our first type in TypeScript, and it's called the any type. Just so that you know, we are working in the same development environment that we had created, and I'm writing all my code in my index.ts file here. So with that out of the way, let's start understanding the any type. Now, any type is the default type in JavaScript that you have already been working with, and it suggests that the value can be of type any. The whole point of using TypeScript is to avoid any type, and that's the default behavior of JavaScript. Let's see this with an example. Now let me declare a variable over here and let me assign it a type of any. This is a syntax to assign types to variables. So the name of the variable followed by a colon and then the type that you want to assign to that particular variable. Now in this case, the first name variable can be of type any. So this means I can store any kind of value in the first name variable that I have over here, and TypeScript is not going to complain even if I change the type of value over here. So for example, I can assign a number to the first name instead of assigning it a string. Now you see over here, first name has been assigned a number and TypeScript is not really complaining about it. So with any type, it can be any type of value. So instead of a number, it can be an array as well. So here I have assigned an array of numbers to first name and TypeScript is not complaining. Now this is a big problem. So no matter what value I assign to this variable, TypeScript will not complain. Assigning any to any variable is equivalent to letting JavaScript automatically infer the value of the variable, and this is what we want to avoid in TypeScript. And this is actually a default JavaScript behavior. So JavaScript tries to infer the type of value that you want to assign to a variable based on the value that you have assigned. So in this case, JavaScript would infer that first name is of the type of value string. But the moment I assign a number to the first name, JavaScript would infer that this is a number. And this is what TypeScript is actually here for. We want to avoid this behavior. The whole purpose of using TypeScript to assign strict types to our values. So though type any exists, it's the last resort. So you have to remember this. You don't want to use any type until there is no other solution available. So it's good to know that this kind of type exists in TypeScript, but we are not going to use this often. There is a corner case that you must be aware of, as there can be instances where you make an error and try to declare a value that is automatically inferred as of type any by TypeScript. Now here I'm going to share an example with you explaining what I'm trying to say. I will write a multiply by 2 function which takes a number as an argument and multiplies it by 2. So let's get on to it. Now here you see TypeScript throws an error at me and says that parameter number implicitly has any type. This is the default behavior of TypeScript, that when it finds any value that is even implied as any type, it throws an error. Now you can override this default value in tsconfig file. Though I'm going to show it to you how to override this value, I would not recommend you do that. I'm going to open my tsconfig file and I'm going to search for a particular property called noImplicitAny. Now by default, this is set to true when your strict option is set to true. And what I can do is, just to show it to you, I can set it to false. Now you will see once this is set to false, I can go to my index.ts file and you will see that this error goes away. Now though the error has gone away, but this has made your function prone to more errors, because now number can be of type string, array, object, and any kind of value multiplied by 2 is not going to give you the kind of results that you're expecting out of this function. I'm going to go to my tsconfig file and I'm going to set this value to true. Now you see we have our error back as well. So the summary here is, even though the any type exists, it is the last resort that you're going to use, and that's all that you need to know about any type. Now let's move on to the next type. In our previous video, we looked at the any type in TypeScript, and in this particular video, we are going to look at the unknown type. The unknown type is pretty similar to any type in TypeScript, but there are subtle differences that we need to talk about. Just so that you're able to reference to the any type code as well in the future, I'm going to create a new directory within my src directory, call it as types, and I will keep copying and pasting each of the types and its example code into that particular directory. Now I'm going to create another file called anytypes and copy this anytype code into that particular file. Now, whenever you want to refer to any of the types in TypeScript and the sample code that we wrote about that particular type, you can navigate to this particular types directory and you will find all the files over here in this particular types directory. Alright, now I'm going to navigate back to index.ts, and this is where we're going to write some code about the unknown type. Let's take example of the previous multiply by 2 function that we wrote in order to discuss the any type. I'll remove this extra code. Now this is the same multiply by 2 function, but in this case, I'm going to set the number parameter to unknown type. Now the moment I assign unknown type to the number parameter, you can see that TypeScript is yelling at me and it's throwing an error. Let's look at what TypeScript says. So the error suggests that object is of type unknown. So what TypeScript suggests over here is that it doesn't know what would be the type of this particular parameter or number in this particular function. So it doesn't know whether it would be able to multiply number by 2, and it still doesn't know whether it would be able to give the expected output, which is true, because if this function is executed with an argument of number, then the output would be something that we expect. But if we use string instead, then the output would not be what really we are expecting from this function. So let's try it out. First, I'm going to execute this function with an argument of type number. Now here I have passed 4 as an argument to this particular function, and let's see what we get as an output. So we get 8. This is what we expected. Now let's try passing a string to this particular function and see what we get. We get nan, not a number. So this is what we are trying to avoid. So you would see this is almost like passing in as any type to this particular function. If I would have had any, I would have had similar problems with this particular function as well. See, it still throws 8 and nan. Now, how is unknown type different from any type then? Let's find it out. The unknown type is a better type than any type. The reason for that is that TypeScript will not let you perform any operation till you are sure of the type of value that you are dealing with. So had it been type any, the TypeScript would not complain about this particular expression. It would leave it up to you to figure out whether number is multiplied by 2 or not. But with unknown type, it throws an error. TypeScript here knows that you as a developer also do not know what kind of value is being passed into the arguments of this function, and hence it throws an error saying that it doesn't know whether this number can be multiplied by 2 or not, or whether the argument is actually going to be a number or not. So before executing this particular expression, if I try to test whether the arguments applied to this particular function is actually a number or not, the TypeScript would be happy with that kind of an execution. Let me show what I mean over here. So here you see, I'm first trying to check the type of the particular argument that we are getting for this function. And this condition says that if the type of argument is actually equal to number, and then go ahead and multiply that number by 2. And if not, we can always return an error message. Since we are confirming that our parameter number would actually be equal to a number, TypeScript is happy over here and it's not throwing an error. We can try these two statements out as well and see what results we get. So for our first execution over here, we got 8, which we expected. And then for the second one, we got the error saying that please provide a valid number. And that's what our program also suggests. So this is what an unknown type is. Now, I won't say that unknown type is super helpful, but it is any day better than the any type. Because here TypeScript forces you to check the type of particular value before you use it within your program. The unknown type is helpful in those cases wherein you do not know while starting the program what would be the actual value of a particular variable, and later on during the program you can test it before applying any operation on that particular value. That's all for the unknown types. Let's move on to the next one. So a boolean type, as the name suggests, always holds values that are either true or false. Let us look at some examples. I'll declare a boolean variable over here. So we have a variable called boolean value, and you can only store boolean values to this particular variable. So as you already saw, we can obviously save literal values to this particular variable, so true and false will work. So as you see, our variable can contain literal values whether it's true or false. So this variable can also contain any expression that returns true or false. Let's have a look at an example. So you see TypeScript doesn't complain over here. What I'm really trying to do over here is test whether type of this string is actually equal to string, which will always be true, and hence the boolean value variable contains true returned by this particular expression, and TypeScript knows that this variable can hold a boolean value and hence it does not complain. Here is another example of an expression. Now, since this expression will always be equal to true, hence no complaints by TypeScript. Now, here are a few examples of what TypeScript won't let you do. So if I try to save an object to this particular variable, TypeScript is going to throw an error. Let's see. Now, the moment I pass an object to this particular variable, TypeScript throws an error and it says type object is not assignable to type boolean. So anything apart from boolean cannot be saved. Let's try a string and confirm this. Again, same error thrown by TypeScript, but now this time it says that type string is not assignable to the type boolean. Now, one important thing that you need to note over here is that undefined and null are not considered as falsy values. So you cannot assign undefined and null to the boolean value variable. Let's try it out. Now, if you see here, if I try to assign null and undefined, TypeScript is throwing an error because it does not consider null and undefined as falsy values. Type null is not assignable to type boolean. And over here it says type undefined is not assignable to type boolean. So just raising a red flag here that null and undefined are not considered as boolean values by TypeScript. In fact, undefined and null are two different types which we are further going to discuss in this particular course. I think with this we are clear about booleans. We can now move on to the next type. So the next type that we are going to look at is the number type. This is pretty straightforward. You can assign numbers to a number type and any kind of numbers. Let's just look at a few examples. So we have a variable called number with the type of number assigned to it, and it's equal to 100. Now you can assign any number to this particular variable, even floats. So floats are also numbers. You see TypeScript doesn't complain here. Negative values are also considered as valid numbers. You see TypeScript still doesn't complain, and -300 is definitely a valid number. Apart from these literal numbers, you can also save an expression that evaluates to a valid number as well. So here is an example of it. In this particular statement, infinity multiplied by 0.01 is an expression, and this evaluates to some number, and hence this can be assigned to a number variable. Here is another example of an expression that evaluates to a number and hence can be assigned to the number variable. So in this particular expression, I am passing a string 12 and then I'm executing the parseInt function on that particular string, which ultimately converts this string over here into number 12. And hence this is assignable to number variable and TypeScript does not throw an error. This goes without saying that now to the number variable, you cannot assign any other value apart from numbers. So I can again try assigning in string to the number variable, but it will not work because TypeScript will throw an error. You see, the moment I pass 121 string to the number variable, TypeScript throws an error and it says type string is not assignable to the type number. So that's all for numbers type. Pretty easy and straightforward. Let's move on to the next type. The next type that we're going to look at is bigint. This is a newcomer to JavaScript and so even to TypeScript. Bigint is different from number types. Let's create a bigint in JavaScript first and see how is it different from the number type. There are two methods to create a bigint in JavaScript. The first way to create a bigint is to use the constructor method. Let's create a bigint by calling the bigint constructor method first. So you can use the bigint constructor method and pass either a string or an integer to it to create a bigint. Another method to create bigint in JavaScript is to use the literal syntax. Let's have a look at it as well. To create a bigint using the literal syntax, you pass in an integer followed by a suffix of n. Now my IDE is throwing an error over here. Let's just look at what it says. It says bigint literals are not available when targeting lower than ES 2020. So in our setup over here, we are targeting ES 2016 and we can get rid of this error by targeting ES 2020 for TypeScript compilation to JavaScript. And we can do this in the tsconfig file. So let's just open our tsconfig file and target the JavaScript compilation from TypeScript to ES 2020. This is my tsconfig file. And if you look here, we are targeting ES 2016. And let's just convert this to ES 2020. Now let's go back to our index.ts file. Now you see the error has gone away. This constructor function also creates a bigint which looks similar to the literal syntax with a suffix of n at the end of the integer. Let's console log bigint1 and see what's the result that we get from the bigint constructor function. If you see over here, the constructor function also creates a bigint with integer followed by the n character. So the question is that if numbers already existed in JavaScript, what was the need to introduce bigints? It turns out that number type in JavaScript can only represent whole numbers up to 2 raised to the power of 53. It's unsafe to work with numbers beyond that range in JavaScript. Let me explain this with an example. Now it so happens that JavaScript defines the maximum safe integer as a constant, and I'm going to save that maximum safe integer possible in JavaScript in a constant and use it. Let me show you how. Now JavaScript has this max safe integer as a constant and is there on the number object. This constant returns the maximum safe integer that is possible in JavaScript. Let me log safeint to the console and see what we get. This is the maximum safe integer that JavaScript allows as the number type. To understand why bigint is needed and it's not safe to work with number types, let's try adding 1 and number 2 to this maximum possible integer and see what we get. So first, I'm going to add number 1 to safeint. And now I'm going to declare another variable called safeint plus 2 and add 2 to the safeint as well. Now we have two variables, safeint plus 1, which adds number 1 to the largest possible number in JavaScript, that is safeint. And then we have safeint plus 2, which adds 2 to the largest possible number, that is safeint. Now I'm going to log both safeint plus 1 and safeint plus 2 to the console and see what we have in store for us. Now you see we get the same output even when we add 1 or we add number 2 to safeint. This means JavaScript cannot go beyond this particular number when it comes to number types. This is the end of number types and this is equal to 2 to the power of 53. What's worse is that even if I try to do a conditional equation and check if safeint plus 1 is equal to safeint plus 2, it will return true. Let's try to do this. You see this returns true, which is not correct. So if you need to deal with a number that is larger than this maximum number and with precision, you would need to use bigint. In order to declare bigint in TypeScript, you just use the bigint keyword while declaring your variable. This is how you would do it. Now I have declared a variable a, the type of that variable is bigint, and I have used the bigint constructor function in order to generate a bigint in JavaScript. You can use the literal syntax as well as long as you're complying with ES 2020. This is an example of a literal syntax. Now this is what you can do with bigint. You can use all mathematical operators, comparison operators, as well as conditional statements with bigint. I will show you an example of a mathematical operator. Let's subtract the number a from number b and see what we get. So I have declared a third variable called c, which is again of the type bigint, and subtracts a from b. Now TypeScript doesn't complain over here because it knows that type of a is a bigint and type of b is also a bigint. So the final result c will comply to bigint as well. Now there are a few things that you can do with numbers but you can't do with bigints. The first thing is that bigints cannot have decimal values. So if you try to do something like this, it will not work. Now you see my IDE is already throwing an error. Let's look at those errors. So with bigint, it says that decimal values cannot be used or the bigint literal must be an integer. And over here, TypeScript also throws an error and it says that type number is not assignable to bigint. So it understands that what we are assigning to it with a decimal is kind of a number and not bigint. Now, apart from this, you cannot use the built-in math object with bigints, which works with numbers. For example, let's try to use the math object and a method of math object on a bigint and see what we get. Now here I'm using the math object and trying to calculate the logarithmic value of the bigint a, but it throws an error, and let's see what the error says. Argument of type bigint is not assignable to parameter of type number. So only number types would work with the math object and bigints won't work with math object. I hope this is clear. This is all that you need to know about bigints, and now we can move on to the next type. I'll see you in the next lecture. In this video, we're going to talk about string types. String types are pretty straightforward. Any value that is between single quotes or double quotes is treated as a string in JavaScript. Let's look at a few examples of string types in TypeScript. This is how you would define a string type in TypeScript. So we have a variable called first name. It is of type of string, and then we have mark in the double quotes. This can be single quotes as well as per your preference, and this is a string type. So mark is a string in JavaScript. Also, any expression that evaluates to a string is a valid string type. Let me show you an example. Now we have a full name variable, which is a type of string. And this expression over here returns a string which takes the first name from the first name variable and then concatenates the last name, that is Doe, to the first name variable. Since full name is a string, all string methods would work on this particular string type. So for example, I can use the split method to split the first name as well as the last name from the full name. Here you see I'm using a split method, which is a string method, and TypeScript does not complain over here because TypeScript understands that full name is of the type string and any string method can be used on this particular type. As with all other types, you cannot save any other type to this particular variable. Here is an example. Now the moment I try to assign a number to full name variable, TypeScript throws an error telling me that only a string is possible. Let's look at the formal definition of the error. It says type number is not assignable to type string. Also, if I try to use number methods on a string type, it will not work. Again, the moment I pass in full name, which is of type string, to the math.log method, TypeScript understands that this is not a number and hence it throws an error. It says argument of type string is not assignable to parameter of type number. This is all about string types in TypeScript, and before moving on to the next type, we will talk about type inference in TypeScript. We'll do that in the next section. See you there. Before we move on to the next types, we need to discuss and understand the concept of type inference in TypeScript. Let's start with a simple example. I will declare a variable first name of type string and assign it some value. We have always been explicitly defining the types of variable, which is string in this case. But it so happens that TypeScript automatically tries to understand or infer a type of a variable based on the value assigned to it. So in this case, if I remove the explicit definition of string, TypeScript will understand that the variable here will have a type of string. Let me remove the explicit string definition and see what we get. So if you see here, TypeScript automatically assigns first name variable as a type of string. This is equal to explicitly defining the type of variable. If I try to save a number to the first name variable, TypeScript will not let me do it. Let me show you. So if you see here, TypeScript throws an error. It says type number is not assignable to type string. Let me comment this and let's look at another example. Now here I have declared a constant and assigned it a value of 85. If you see I have not assigned it any type, let's see what TypeScript has inferred from this. If you see TypeScript has assigned it a type of number 85, this means TypeScript has gone a step ahead and has explicitly declared that the number constant will always have a value of 85 since it is a constant and constant values cannot be overwritten in a program. What would have happened if this would have been a variable instead? Let's have a look. Now you'll see that TypeScript has inferred this as a type of number. TypeScript is intelligent enough while using inference and understands that since number 2 is a variable and can be overridden, hence it assigns it a type of number because we have assigned a number value that is 90 to this particular variable. So the question is whether you should rely on type inference or explicitly define types of each of the values. And the answer is that it depends. In the above two cases, it's better to rely on type inference rather than declaring types of each such variables because assigning types to these variables is redundant. It's the best practice to let TypeScript infer the types of values it can on its own and only explicitly declare types where it's needed. Let's look at an example. Let's say we have another variable called final result. And we have not assigned it any value, and the value needs to be computed by adding two numbers. If we add two numbers, we know that at some point in the future, the value of final result will always be a number type. And since TypeScript here cannot infer the value of the variable final result, we have to explicitly tell TypeScript the type of final result will always be number. Right now, TypeScript infers final result variable to be of any type, and this is not what we want. And hence, I will go ahead and assign final result a type of number. Then at any point in future, we can assign it number as a value. So if we have a function that adds 10 and 15 and calculates the final result, that would be an ideal use case for it. So let's write a function that adds number 10 and 15 and returns a number, and hence final result would get a number. Now since we have our function ready, I can assign the value to the final result. Now here you will see that TypeScript does not complain because TypeScript knows that this particular function add number would return a number and a number can be saved in final result. because final result was declared as a variable previously and its type was assigned to number. As we progress further along the course, we will understand in a better way where we can rely on type inference and where we need to declare our types explicitly. For now, all we need to take away from this is that we rely on type inference by TypeScript whenever we can and declare explicit types where we need to. I hope this is clear. I see you in the next lecture. In this video, we are going to have a look at the object type in TypeScript. We will first declare an object in TypeScript and see how TypeScript infers it. So let me quickly create a person object. So we have our person object here, and now I will add two properties to the person object. The first one will be the name of the person. Now I will add another property, that is the age of the person. Now let's see what TypeScript infers from this. If we look at the person object, TypeScript accurately infers that person variable will be of type object and it will have two properties, that is name, which will be of type string, and age, which will be of type number. If I hover over the individual properties of the object, TypeScript is able to infer them correctly as well based on the values that have been defined to them. So here, name is inferred as of type string and age is inferred as a type of number. What if I need to create a definitely type object and cannot rely on TypeScript's inference? This is how we can do it. We can declare an object using the literal syntax first. So let's declare a car object this time. This is how you would normally declare an object in JavaScript using the literal syntax. To tell TypeScript that car is an object, we use the same syntax as we did for other variables for type declaration. Let me show you how. So we use a colon followed by the object literal syntax immediately after the variable name. Now this doesn't tell TypeScript much about the properties of the car object and it's not very helpful. It just tells TypeScript that car would be of a type of object. We can go ahead and assign some properties to this object and tell TypeScript the type of properties that will be there within this object. So within this object definition, we can assign properties and their types. So let's add a color to our car, which will be of type string. Let's add another property called brand, which will be again of the type of string. So now you see TypeScript is already throwing an error, and the error says that type of object is missing the following properties, color and brand. So since we have defined the properties of this particular object as color and brand, our real object does not contain the color and brand properties, and that's why TypeScript is throwing an error. So let me add color and brand properties to our real object. Now the moment I add these two properties to my object, TypeScript is happy and it does not throw any other errors. One more thing that I want to point out over here is that you should look at the difference in the syntax while we are defining the properties of an object and their types. You will see over here that the property name is followed by the type of value and then a semicolon. But while declaring objects in JavaScript, we use commas after each property. But here we are using semicolons defining types. This is a subtle difference that you would need to keep in mind while declaring properties of objects. So how is predefining the properties and their types of an object useful to us? Let me explain you with an example. Let's assume that we are creating a blogging platform and we have an article object. This article object will always need to have some properties assigned to it. So let's declare that article object. So you will see that I have just created a variable article over here and defined its type as an object. Now I'm going to add some properties to this particular object. So let's say our article will always have an author, which will be of type string. Then our article will always have content as well. Again, this will be of type string. And finally, our article will have a title which will be of type string as well. I have included my types in quotes by mistake, so let me just rectify that. Now you see that we have declared the structure of our article object, and in future, whenever we will create a new article, TypeScript will prompt us to include all the mandatory properties of the article object. Let's try to create an article object and see it for ourselves. You'll see that the moment I create an empty article object, TypeScript throws an error, and let's see what that error is. So it says that type object is missing the following properties: author, content, and title. And that's what we know already. So let me go ahead and add all these three properties to our article object. First, I'm going to add the author. Then I will add the content. And finally, I will add the title. Now, the moment my article object has all the three properties, there's no error. Before I conclude this video, there is one more thing that I want to discuss. There can be instances when you need a property in your object which is not mandatory or is optional. Our article here can have an image property which is a URL to an image and it is optional. So let me show you how you can do that. Let me first create an image property within our article and define its type as string. Now, the moment I add this image property, TypeScript again throws an error, and this time it says that the property image is missing on this particular type of object. In order to make any property optional, all you need to do is add a question mark at the end of the property name. And that's what I'm going to do over here. So just after image, I will add a question mark here. The moment I add the question mark, TypeScript understands that this property is optional, so it does not throw an error. So this is how you define optional properties within your objects. I hope this is clear, and with this, we can now move on to our next lecture. See you there. Till now, we have been declaring the type of object using this inline syntax of declaring the shape of the object, followed by assigning the values of each of the properties of the object. For the objects which have few properties, this might be a quick and easy way out. But think of a scenario where there are a large number of properties in an object, and defining your types like this would become rather cumbersome. It turns out that TypeScript has a better way of dealing with custom types, and it involves using the type keyword. Let's have a look at an example. So we have this article object from our previous lecture, and the article object has all these properties defined. So we have an author in an article, which is the type of string. We have a property called content, again string, title and image. Each of these are strings as well. Once we have defined the properties of the article object, we can then create the article itself with all these mandatory properties. So here I have created the article with all the mandatory properties, and since image is not mandatory, I've left it and have not created as a part of the article. This method has certain limitations to it, and first one being that it is verbose and confusing. I would argue that this becomes confusing as and when the application grows, as you declare the object somewhere else and then assigning the value to the object somewhere else. This becomes very difficult to manage in large applications. Also, for some, the syntax itself is confusing as well, and it takes some time and practice in order to read this kind of code, where you are declaring the shape of an object and then later you are declaring the object itself using the literal syntax, and you are assigning each of the values of the object properties at a later stage. As I said previously as well, TypeScript has a better way of dealing with this. We can use the type keyword to create type aliases. Let's see how. So instead of defining the shape of the object like this, what I'm going to do now is I'm going to create a type alias and name it as an article. In order to create type alias, we use the type keyword like so. So if you see here, I have created a type which is of the type article and is equal to an empty object right now. So within these parentheses, we can define what the article type would contain or the properties that the article type would contain. So I'm going to copy all these properties from here and I'm going to paste them between these curly braces. So now we have a type which is article and all the article types should have these properties. Let me get rid of this old code. Now I will create a new object called article. Now we want this article variable to be of the type article and we can use our colon syntax in order to do so. Now our variable article is of the type article and you can already see that TypeScript is yelling at me and is throwing an error. Let's read the error and understand what TypeScript is trying to tell us. So TypeScript understands that the variable article is of the type article and it is missing author, content and title, which are the mandatory properties in our type article itself. Now let's go ahead and assign these mandatory properties. Now you will see that the moment I have assigned these mandatory properties, there is no error that is being thrown by TypeScript. Declaring a custom type makes it reusable as well. You might have a scenario where you have another object called post which has the same properties as the article type, and in that case you can reuse the article type as well. So let's go ahead and declare a new object called post and make it as a type of article as well. We have a new object called post and now we can assign all the mandatory properties of the type article. Here you see we have two variables now. One is called article, the other one is called post, and both of them are of the type article. Since we now understand type aliases, let's dive deeper into other benefits offered by type aliases as we understand the union and the intersection types in our next lecture. See you there. Since now we understand type aliases, we can have a look at the union types as well. A union is a combination of two types. If I had to represent a union type using a diagram, this is how it would look like. A union of two types can have properties of either one or both of the types. Let's have a look at some code to understand this in a better way. I'm going to first declare a type called dog. Now let's assign some properties to our dog type here. The name, which will be of type string, barks, this will be of type boolean, and finally wags, which will be of boolean type again. Let me make this capital. Now so that we are able to see a union type in action, I will create another type called cat. Our cat type will also have two properties. First will be the name, which will be of type string, and second will be pers, which will be of type boolean. Since now we have two types here, we can create a union of both these types. So let's do that. In order to create a union of type dog and of type cat, we would need to use the pipe character. Let me show you how. Now this is how you create union of two types, and this is a union type of dog and cat, and it gets all the properties of either the dog type, the cat type, or the properties of both dog and cat. So let's see this with some code in action. To illustrate that it gets all the properties of the dog type, I'm first going to create a dog object which will be of the type dog and cat union, and it will have all the properties of the dog type. So I have created a variable dog and it is of the type dog and cat union. Now this dog variable can have all the properties of the dog type. So it can have a name. So here you will see that TypeScript understands that it's a union type and does not throw any error even though properties from cat are missing. Secondly, the union type also gets all the properties of the cat as well. Let's declare another object called cat and assign it all the properties of cat having the type as dog and cat union. Let me make some space here. So if you see, I created a cat object which is of the type dog and cat union, but it gets all the properties of the cat and TypeScript does not complain over here. So with union types, the dog object is a pure dog which contains all the properties of the dog, and the cat object is a pure cat which gets all the properties of the cat. The advantage of union types is that we can create a hybrid animal as well, which has all the properties from cat as well as from dogs. Let's create one hybrid animal and see how it works. So we have created another object called dog and cat, which is again of type dog and cat union. Now this will contain all the common properties between dog and cat. So we have the name property first. Then barks, then wags, and finally purrs. So you see our hybrid animal over here does not wag but purrs but barks as well. So it's a combination of dog and cat types. So once again, a union type can either be a dog or it can be a cat or it can be both cat and dog. One thing to note here, a union type has to have all the properties of one of the types. So it cannot have a missing property. So if I remove wag and purrs from this, we will get an error. So TypeScript understands that the object that we have here is not a complete dog or not a complete cat object, hence it throws an error. So in summary, union types is either the dog type or the cat type or all the common properties of dog and cat combined together. Since we understand the union types, we will look at a few practical examples of how union types can be used using the primitive types in TypeScript in the next video. So see you there. Union types are often used along with primitive types as well in TypeScript. Though we have not understood what an intersection type is, it would be fair to say that union types occur more naturally while you're programming as compared to intersection types. We will look at intersection types in the upcoming videos. But for now, let's have a look at a real-life case where a union type would be needed, and we will make union types using primitive types that we have already learned. So here I am going to write a new function that adds up a number as well as a string. Now this function will take in two parameters, a and b. Since I want this function to add numbers as well as to concatenate strings, both of these parameters, that is a and b, can be numbers as well as strings, or even one of them can be a number and one of them can be a string. This is where we can use union types to tell TypeScript that parameter a and b can either be of the type number or string. So let's declare a and b as union types of number and string. First for a will be either number or string, and same goes for b. Let me capitalize that. Instead of repeating our code twice for both of our parameters, we can declare a custom type here as well. So let's go ahead and declare a custom type called type string or number. So now we have a custom type called string or number, which can either be a number or can be string. So let me replace this verbose code with our type annotation. Since we have our type annotations in place now, we can implement this function. First of all, I will check if both the arguments passed by the user are numbers. So I will have a condition inside this function. So here we are checking if type of A is a number and type of B is also a number. In that case, we are just adding those two numbers and returning the value. Now, if any of these two arguments, that is A and B, being passed in by the user is not a number, that means we need to convert both the arguments to a string and then return the value. So let's do that. So here you see that it really doesn't matter whether A is a string or B is a string or both of them are strings. If both of them are strings, we are just concatenating them. And if any of those arguments is a number, we are converting them to string and then again concatenating them. Now we can test our function by passing in different kinds of values. To start with, let's pass two numbers as arguments and see what we get. So here I have invoked the function and I have passed 5 and 10 as arguments. So let's refresh and see what values we are getting. We get 15 and that's what we expected. Now let's try passing in a string and a number. So I'm going to duplicate this and instead of 5, I'm going to pass a string. Here we get mark 10 and that's what we expected. In this case, you can see our function converted both the values to string and concatenated them into one string value for us. This gives you type safety as well, because if I try to pass anything apart from string or a number to any of the parameters of this function, TypeScript will throw an error. Let's see that in action. I will try to pass one null value to any of these arguments. So instead of 10, let me say null. The moment I do that, TypeScript throws an error. Argument of type null is not assignable to parameter of type string or number. So this is how you get type safety for your function. Anything apart from string and number will not work. So these are union types in a nutshell and a trivial example of why and how you can use primitive types and combine them using union types to your advantage. We will now look at intersection types in the next lecture. See you there. Apart from the union types that we have already looked at, TypeScript offers us intersection types as well. If we look at these diagrams, union types are a sort of sum of two types A and B, whereas intersection types is an intersection of common properties of both the types along with the unique properties of each one of them. Let's understand this with an example. I will again create two types, cat type and dog type, for this example. So let me start with the cat type first. So type cat will be an object and let's add some properties to our cat. So our cat type will have three properties: name, which will be string, pers, which will be a boolean, and color, which will again be a string type. Now let's create the dog type as well. Now here is our dog type and let's go ahead and add some properties to it. So our dog contains three properties as well. First one is the name of the dog, which is a string. Whether it barks or not, that's boolean, and color, which is again a string. Now we can create an intersection between these two types and we can use the % symbol in order to create an intersection between any two types. Let me show you how it is done. So we will create a new type called hybrid animal. And this will be an intersection of dog and cat type, like so. Our hybrid animal has all the unique properties of cat as well as of dog. Now TypeScript will take all common properties from the dog type as well as from the cat type first. So let's see what all common properties we have. Name is common between cat and dog, so that is a common property. Color is common between cat and dog, that's again a common property as well. Now apart from common properties, TypeScript will pick up unique properties also. So from dog it will pick up barks, so that's a unique property in dog, and from cat it will pick up purrs. So our hybrid animal will eventually have four properties, that is name and color, which are the common properties between two types, and it will also have purrs and barks. Let's try to declare an object and check it out for ourselves. Let me create a new hybrid animal. This is going to be of type hybrid animal. Now let's name it as Max. Color can be white. Now instead of adding both the properties of barks and purrs, let me just add barks first and show you a major difference between the intersection types and the union types. So I'm going to add barks and set it to true. You see, even if we add barks, which is the complete properties of the dog type, TypeScript still throws an error because TypeScript knows that hybrid animal is an intersection of dog and cat. So over here we get an error which says that name color barks is not assignable to hybrid animal, property purrs is missing. So this is the major difference between a union and an intersection. Union types can be of either type dog or can be a cat type, but in case of intersection, it is all the unique properties combined with the common properties of the two types. So let me add purrs to it and then this error is going to go away. Here you see the moment I add purrs, the error goes away, and that is what defines an intersection type. Now in real world scenarios, most of the times you would end up using union types instead of intersection types. But having said that, it does not mean that intersection types do not have any use cases. It's just that they occur less often as compared to the union types. This is how intersection types work, useful where you need to pick up the common and unique properties of two types. That's all for this one. I will see you in the next lecture. Thanks for watching. Before we conclude our basics about the types in objects and move on to arrays, there is one final topic I want to talk about, and that is index signatures. While we program, we often encounter situations where the exact keys and values of object properties are not known to us, but we do know the pattern of such keys and properties. Let's look at such a case with the help of an example. Let's assume that we are building a ticket management system for an airline, and they need to keep a track of all the seat numbers and passengers traveling on those seat numbers. For that, let's first create an airplane type. I will declare a custom type and call it airplane. Now let's add some properties which define the details of this airplane object. So our airplane can have a flight number. This can be of the type string, then the airplane model itself, which is again a string. Then we can have date of departure and time of departure, and let's keep them as string values for the sake of example. Then we can add two more properties to our airplane, that is from and to. So from where the plane is departing and the destination to where it is going, and both of them can be string values. So let me go ahead and add them. I think these properties are enough for illustrating what we are trying to do here. Each plane of our airline must have these properties. Let's create an airplane object based on the above airplane type. So we have a new object here, airplane, which is of the type airplane. So let's start by adding all the properties of an airplane, starting with the flight number. Let's add the airplane model as well. Date of departure. Time of departure. From where the plane will depart. And its destination. This is something that we already understand and have repeated in many of our previous lectures or videos. As I pointed out previously, each plane needs a list of seat number and the name of the passenger traveling on that seat. All the planes will have different number of seats depending upon the model of the airplane. So if I had to assign seat numbers to this plane in the simplest form, this is how I would do it. I will create another property in this object and call it seats. Let's ignore the TypeScript errors for the moment. This seats object can contain the seat number and the passenger name like so. Now in real world scenario, I might just have seats as an array and each of the passenger traveling in the seats as an object and then assign properties to that object. But for the sake of our example, I have structured it this way, which is simple and will illustrate what I'm trying to say very clearly. So now we can see that TypeScript is throwing an error at us, and let's just try to see what TypeScript is saying. So it is saying that seats does not exist in the airplane definition and it's an extra property. So definitely we have to add seats to our airplane definition. Now the simplest way to solve this problem is by adding seats and making seats as an object. So the moment I add seats object to my airplane definition, TypeScript no longer throws an error because it understands that seats is going to be an object. But this is not an elegant way of doing it because it gives rise to another problem. The object that we have declared is of type any. So this can be any object. Since this is any object, I can add anything to it. So even if I add seats like this, which do not give me any information about the seat number or the name of the passenger, TypeScript will not throw an error. And this is not what we want. We do want to have some sort of a control on what kind of an object this seats object is going to be. In this case, I can basically assign any key value property to the seats object, and that's what makes my program vulnerable. To solve this problem, we have something known as index signatures in TypeScript. Let me show you how index signatures can be defined. In order to have a look at that, let's go back to our airplane definition. Over here within seats, we can say that seats will always have a key, and this key will be of the type string, and the value this key will hold will also be of the type string. This here is an index signature. This essentially states that seats object can have a number of properties as long as the name of the property is a string and the value assigned to that property is also a string. One object can only have one index signatures, so you cannot have two index signatures for the same object. But yes, you can use union types for index signature. So I can say that the key can be of either type string or it can be of the type number, and even the value of this key can be of the type string as well as a number. So that is something which is possible, but we cannot have multiple index signatures within the same object. Only one index signature will exist inside an object. So let me revert this back only to string. Now let's go back to our airplane object and see if we get an error, which we are getting because TypeScript now understands that this kind of a property cannot be passed to the seats object because The key has to be a string and even the value needs to be a string. So we can go ahead and remove this. Going back to our airplane type definition, there is one more thing I want to point out about index signatures. Index signatures can coexist with other values as well. So I can have another property which defines the order from where my seats start. So since my seats are starting from A, I can have order property set to A. But one thing to notice over here is that the other property that I'm adding is also of the type string. So if your index signature defines this sort of a pattern, you have to follow it in other properties as well. So if my order properties was to be defined as a number, it will not work. So TypeScript will throw an error over here where it says property order is of type number and is not assignable to string index type. So if I need a number over here, I would have to add a union type of numbers as well, and then the error will go away. I will get rid of this property and even the union type. I know it's a bit difficult to get your head around the index signatures and the union types, but once you start practicing and you start using them, things eventually do get clear. If it does require you to watch this video once again or refer back to this video whenever you need to use index signatures. I think this clarifies index signatures for you. In our next video, we would move on to arrays. So see you in the next one. Let's try to declare a few arrays and see how TypeScript infers them automatically. So let me create my first array here. So here we have an array of numbers and let's see what TypeScript understands from it. If you see, TypeScript correctly infers that A is an array of numbers. Let's declare an array of strings and see what happens. So here we have an array of strings and let's see what TypeScript infers from it. So TypeScript again correctly infers that B is an array of strings. Now let's declare another array which is a combination of string as well as numbers. So C is an array which contains both strings and numbers, and let's see what TypeScript infers from it. So here, interestingly, TypeScript infers that C is a union type of string and numbers and is an array. So array of union of string and numbers. So this means our array can contain either string or numbers. Now let's look at what is the official syntax of declaring an array of numbers. Over here we have A, which is an array of numbers and is being inferred correctly by TypeScript. But if we had to strictly type this on our own, how would we do that? So again, using the colon syntax, we would just say number followed by array. So this is the syntax of declaring array of numbers. In this syntax, we use the type of values in the array followed by the literal syntax for array. We can also use an alternative syntax which makes use of the array keyword. Let me show you how. So over here, B is an array of strings. So using the alternative syntax, if we had to define this as an array of strings, this is how we would do that. So here we define that it's an array of strings and we use strings within the angle brackets. Both of these syntax mean the same thing and there's no difference when it comes to performance or inference. However, for convenience sake, for arrays throughout the course, I will use this first syntax which involves the use of the literal syntax for arrays. But we would have to talk about the second syntax in a lot of detail when we talk about generics ahead in the course. But for now, for all the arrays, I'm going to use this particular syntax. Why don't you pause this video and go ahead and try defining the type of this particular array. Just pause the video right now if you want to try it out. Were you able to do that? Let's see how we can define this as a union of string and numbers. So first of all, we know that C is an array, so I would use the array literal syntax. And since I want to say that our array can contain string and number as well, I can define a union between the brackets. So between the brackets, I can say string or number. So this tells TypeScript that our array can be of either type string or it can be of either type number. As a rule of thumb, while working with arrays in TypeScript, you want to ensure that your arrays contain a single type of value. This is because then you would not have to conditionally test each value while working with arrays. So in case of working with array C, we would always have to check if the value is a number or a string before we can call any method, because we don't want to end up calling string methods on a number, which would eventually lead to an error. Till now, we have assigned primitive values to our arrays. We can also assign custom types to arrays as well. Let's bring in the airplane type from our previous example and see how we can make an array of airplanes. So here we have our airplane type from previous example. So in our travel booking website, if we want to have multiple airplanes and we want to specifically declare an array of airplanes, this is how we can do that. This is a single airplane, and let's go ahead and define an array of airplanes. So I can say type airplanes is equal to an array of airplane. Now type airplanes will be an array of this particular type, which is a single airplane. Now for the sake of an example, I can declare an airplanes array and have multiple airplane objects within that particular array. So let's go ahead and do that. We now have an array called airplanes, which is of the type airplanes and which is an array of airplane objects. So let's go ahead and paste multiple airplanes within this so that you can see it. So I'm going to include multiple airplanes within this object. Now you see our airplanes array has 2 airplanes within it. Again, what I want to point out with this example is that array here is of a single type. It does not contain cars as well as airplanes, and hence this makes it easy dealing with each airplane object as we are dealing with a single kind of value, and there is much lesser chance of encountering an error while looping through each of these values in the array. I hope this is clear. Let's move on to the next lecture. JavaScript by default doesn't have tuples baked into it, while some other programming languages do support tuples. Tuples can be considered as special types of arrays where the length of the array as well as the type of each of the values in the array is predefined. Let's have a look at a simple example to understand what is a tuple. Let's assume we need to declare an array which represents a person and has 3 values in it. So we want 3 values in this array, where the first value should be the first name. The second value should be the last name of the person. And the third value should be the age of the person. So let's declare person array first of all. This will be of type array. But we want this array to have only 3 defined values, that is the first name, the last name, and the age of the person. So the first name is going to be a string, the second name is going to be a string as well, and the age is going to be a number. So in order to define that, I can type it in this way. So here we are saying that person will be an array, and this array will contain the string, which is going to be the first name. The second value of the array is also going to be a string, which is going to be the last name. And the third value of this array is going to be a number, which is the age of the person. Now this example over here is a tuple. In other words, this is an array with fixed length. So this will always have 3 values, and the values will be of type string, string, and number in the exact same order, which is represented in this array. Let's try to assign values to this tuple. So I can say person is equal to, the first name can be John, the second name is Doe, and we can assign the age as 18. Now here the person complies with its definition, string, string, and number. Now instead of this number, if I try to pass in string, it will not work. The moment I convert 18 to string, TypeScript throws an error. it says type string is not assignable to type number. So it understands that we have declared a tuple over here and we need to comply with this particular structure of the array. Let me revert this back. Just like objects can have optional values, tuples can also have optional properties. So if you want to make third property of number as an optional property, I can do that using the same question mark syntax that we use in objects. So if I place a question mark after the number, it will become an optional property. Since it has become an optional property now, I can remove 18 and TypeScript will not throw an error. And the moment I remove the question mark and number is no longer a property, TypeScript does throw an error and it tells me that the number is missing in this array. So we can have optional properties as well in tuples. One more thing I want to point out about tuples is that they can let you create heterogeneous lists as well. Let's take an example of a list of passing and failing students in a class. We want to create a list that has the following values. So in this example, I want to create an array which contains the following properties. So this is an example array that I want to create which has the following properties. I want the first value of the array to be a number which will represent the number of students for me. And the second property in the array, I want it to be a boolean which represents whether this list of students is of the students who are passing or failing. If the second value is true, I will come to know that the list of students is of the students who are passing, and if the second value is false, I would come to know that the list of students is of the students who are failing in the exam. So in order to comply to this particular structure, I can create a tuple. So let's go ahead and create a custom type called list of students. This list of students is going to be a tuple, and this tuple will have the first value as the number. The second value will be a boolean, as we discussed. So the third value has to be an array of strings which is spread out within our array. So we can use the JavaScript spread operator over here, and we can say that the next value will be the array of strings which is spread out within this array. So now our list of students, the first value will be a number which will tell us the total number of students that are there in the list. The second value will tell us whether these students in the list are passing students or failing students. And then we will have the list of students separated by a comma, which will be each of which will be a property in our array. So let's go ahead and create passing students first. So I can say passing students. This will be of type list of students. We have total 3 passing students. And I have to set this to true because I know this is passing, these are passing students. And then we can give the name of the passing students. So let's have John, who's passing. Then we can have Stella, followed by Mark. Let me make some space here so that you can see. So we have list of passing students. There are total 3 students. This is passing because true. And then we have 3 students, John, Stella, and Mark. Now let's create a list of failing students as well. So we have a variable failing students, which will be an array of list of failing students. And we just have one failing student. We have to say false because this guy is not passing, and the name of the student. Passing students and failing students are tuples because the shape of the array is clearly defined over here, but it's a heterogeneous list because the number of students or the number of properties in this particular array can vary as well. Tuples help you strictly type your arrays, and you must use tuples as often as possible. I hope this is clear, and I will see you in the next video where we're going to talk about the read-only arrays. As we all know, arrays in JavaScript and TypeScript are mutable. This means once you declare an array, you can change it. You can add or remove values from an array, which is the kind of functionality you want most of the times. But TypeScript comes with a functionality to make arrays immutable, which means to convert arrays into read-only values which can only be read but cannot be changed. To create read-only arrays, you just have to use the read-only keyword while creating or declaring your arrays like so. So let me create a read-only array called number here. This will be an array of numbers, and let me assign a value to it as well. So here we have a read-only array, and this array is called number, and this is an array of numbers. And this has an array which has value of 1, 2, and 3. Now this array is read-only. If I try to add any new value to this array, TypeScript will throw an error. Let's try to do this. So here you see whenever I try to add a new value using the push method, TypeScript throws an error. Let's look at what TypeScript has to say. Property push does not exist on type read-only number array. Most of the times you will create a read-only array either to just read from it or copy it. Whenever you have these two use cases in your application, you can use read-only arrays. Just like arrays, you can create read-only tuples as well. This is how you would do that. For this example, let me create a custom type called read-only-person. So read-only-person is going to be an array, and this array will include 3 values. The first value we are assuming it to be the first name, so I'm going to make it as string. The second value is going to be the last name of the person, so that's going to be string as well. And finally, the last value is going to be the age of the person, so I will assign it as a number. In order to make this read-only, all we have to do is use the read-only keyword before the type declaration, like so. Now this is a read-only tuple. Now based on this read-only person type declaration, we can create a new person array. So let's do that. This is going to be read-only person, and then it's going to be an array. The first name is going to be John. Second name can be Smith. Age can be 32. So here we have a person which is a read-only person, type which in turn is a read-only tuple, and this is the value that is being assigned to it. Now it turns out that there is a long form syntax to create read-only arrays and tuples as well, just like the one we have for creating arrays. So if you want to have a read-only array of strings, this is how we can do that. Now this syntax uses the angle bracket notation. So first you're using the read-only keyword, then followed by angle brackets, and then inside the brackets you are letting TypeScript know that this is going to be an array of strings. This is pretty similar to the long form syntax for declaring arrays as we saw in the previous videos. But again, throughout the course I will stick to this kind of a notation while declaring read-only arrays. As I promised, we would talk more about the angle bracket notation while we talk about the generics in TypeScript. And we have a complete forthcoming section of generics in this course itself. This long form syntax can be used for declaring tuples as well. So if we have to declare a similar tuple, we can use this long form syntax. Let me show you how. Let me just duplicate this and type, we can call it C. So rest of the syntax remains the same. It's just that instead of saying that this is an array of strings, we have to declare it as a tuple. So inside the brackets, we can say string, string, and number. Now this has become a tuple and it will only take in 3 values. The first value is going to be string, the second value is going to be the string as well, and third value is going to be a number. As far as the syntax is concerned, you can use the one you like. There is no hard and fast rule about it. I personally don't prefer to use the long form syntax and will continue to use this syntax throughout the course. This is all about read-only arrays and I hope this is clear. I'll see you in the next video. JavaScript has 2 primitive types that represent the absence of something. Now one of them is null and the other one is undefined. Many programmers use null and undefined interchangeably, but they are different from each other. though the difference is subtle, but it does exist. Undefined means something that has not been defined as yet, and null is something that JavaScript has not been able to compute and ran into an error. Let's see them in action. Let's declare a variable called user, and this user variable is going to be of a type string. Now let's try to log the value of the user variable to the console. Now you see TypeScript throws an error over here and it does not let me log the value of the user to the console. Variable user is used before being assigned. This essentially means that we have not assigned any value to the variable user, but still we are trying to use it. So TypeScript is trying to avoid an error over here. So what I'm going to do is I'm going to go to my tsconfig file, and in my tsconfig, I'm going to set no emit on error to false. This way, even if our script has an error, TypeScript will go ahead and execute it and log the value of the user variable that we have to the console. So let's go back to our index.ts file. Let's give it a refresh. Now you see TypeScript has logged undefined to the console. So we know the user is undefined. Now this is in sync with the definition of undefined. It's a value that has not been defined as yet. Let's look at an example of a null value. I will try to get an element from the DOM which does not exist. Let me declare a variable over here. So we have a variable called save button, and let me try to get a button from the DOM which does not exist. So I'm going to use document get element by ID, and I'm going to pass the save ID. Now I already know that there is no ID called save in my DOM, and save button is definitely going to be a null value. Let's log save button to the console and see what we get. As we expected, we got null. Null values are a pain point for developers as you have to check your code time and again for null values, else you're bound to get errors. TypeScript protects us against undefined and null values. Let's see how. Since we now understand null and undefined, I'll get rid of this code. Now let me create a new variable. The variable name is logged in username. This is going to be of type string. And I'm not going to define this username right now. Now let me create an array of users with 2 users in it. So we have a users array and we are going to have 2 user objects within this. Each user object will contain a name and the age of the user. So our users array now has 2 users in it. Now this depicts a real world scenario where in an application we have the username of the person who is logged in, so logged in username, and we want to find that user from this users array. Within my application, at any point if I want to find the correct user which is logged in, I can use the find method available on arrays. So I can have a const logged in user which is equal to users.find. Find method on users takes in a function known as a predicate. So if that function returns true, that particular object will be returned as a logged in user, and if the function return false, nothing would be returned. So it will go through each of these objects and try to find the condition that we put in into this predicate function. So it will take in a function which will go through all the users, and we need to return true if user.name is equal to logged in username. So let me make some space here so that I'm able to explain this in a better way. So logged in user is equal to users.find. So we are running this find method on the users array. This find method goes through each of the users in the array. So we get user. So we get each user as an argument in the predicate function that we pass over here. And then we are checking if user.name is equal to logged in username. Now logged in username, if we see, is actually the first variable that we created, and we said that this is going to be a string, but that variable is still undefined. Now just so that we are able to see our errors before compilation, I'm going to go back to my tsconfig and I'm going to set no emit on errors to true. I just set it to false to show you the undefined and the null values. Let's go back to our index.ts file. Since we understand the whole setup here, and we know that logged in username is just declared but is never defined, you'll see that TypeScript has not thrown an error as yet. Now let's try to access the age of logged in user and see what happens. You see, the moment we do that, TypeScript throws an error. So TypeScript protects you from accessing values that are not defined. Let's also see if TypeScript provides us any protection against null values as well. To do that, I'm going to bring in the save button variable which we had, in which we were trying to access a document property which did not exist. Over here you will see that I have not defined the type of value that I'm expecting for save button. Let's see what TypeScript is automatically inferring its value to be. So if you look at TypeScript inference, TypeScript says that save button would either be of the kind HTML element or null. So TypeScript does understand that this value might be null. This is one of the instances where you might not want to rely on type inference and explicitly declare the type of value that you're expecting your variable to hold. So I will go ahead and define this value to HTML element. Since I did not use a union of null and HTML element, I just use HTML element. Now TypeScript understands that we are certainly expecting an HTML element over here, and the save button variable cannot be null. So over here you see that TypeScript throws an error, and this error essentially means that this value can be null as well, and you and me as a developer, we do not know whether document.getElement by ID and this particular ID will return some value or not. Now there are two ways to get rid of this error. The easier way to do this is to tell TypeScript that we as a programmer know that this will have an element with ID save in our DOM. For that, we can add an exclamation mark to the end of our code. This exclamation mark tells TypeScript that we as a developer know that this statement will definitely return an element which will have an ID save, so TypeScript can stop worrying about it. The moment I add the exclamation mark, you will see the error goes away. Second, and the preferred method of getting rid of this error, is to let save button be a union of HTML element and null. Now in this case, you will always know that save button is of the type either HTML element or is of the type null. So whenever you want to use HTML element in your JavaScript program, you would have to do a type check. So for example, whenever I want to use save button, I would pass a condition like so. So with this kind of condition, I will always check if save button is not equal to null and then perform whatever my program intends to. This covers null and undefined types for us in TypeScript, and in the next video we are going to look at the void and never types. So I'll see you in the next video. The void and never types do not exist in JavaScript, but they do exist in TypeScript. So if you're coming from another strictly typed languages such as Java, you are probably aware of the void and never types. There's a subtle difference between a void and never type, and to understand that, let's start with the void type. Void is assigned to a function which does not return any value. Let's look at a simple function. So we have a simple function here which just adds 2 plus 4 and logs it to the console. Now let's execute this function and see what we get. As expected, number 6 is printed to the console, but you will see that this function does not return anything. it just prints the value 6 to the console. I will hover over the function name and see what TypeScript has inferred this function type to be. So you see TypeScript correctly infers this function to be a void function. A void function is a function which does not return anything. So any function in your program that does not return any value can be assigned a type of void. Now let's understand the never type as well. The never type is assigned to a function that never completes. Let me give you an example over here. I will declare a new function and I will call this function as throw_new_error. And inside this function, I will just throw a new error so that this function never completes and always throws an error. This function will terminate as soon as this function is called in our program and will stop running because it will throw a fatal error. This kind of function can be assigned a type of never because this will never terminate. So we can assign this function a type of never, and let's assign a type of void to our addNumber function as well. Now let's just execute this function and see what we get. So you see our void function prints 6, whereas our throw_new_error function just throws the error that we had declared. So the difference between void and never is that void function does not return any value but can perform any other procedure. Unlike the never type, it does complete and TypeScript moves on to the next line of code once it has completed executing the void function. On the other hand, a function assigned as a type never will never complete and the program terminates. This pretty much sums up the void and the never types in TypeScript. I will see you in the next video. In this video, we're going to talk about another TypeScript type called enums. Enums are types that are used to enumerate the value of a data type. If you have used SQL databases such as MySQL, then you are probably aware of enums. If you haven't, then don't stress, as this is what we are going to understand throughout this video. In order to understand enums, let me start by declaring a simple person type in TypeScript first. So we have a person type here and let's assign it a few properties. Let's give it a name, which will be a string, an email, which will be a string as well, and finally a password that will again be a string. This is something we are already aware of and have been doing till now. Now let's assume that we have to assign a role to each of the person as well. Now in a real world application, each person object that we create from this type person can have a different role. We might have a fixed set of roles such as an admin, an author, an editor, and those roles would be used throughout the application across different person objects. So what options do we have in order to define these kind of roles? The first option that might come to your mind is to declare an array of roles. So we can definitely declare an array of roles and we can do something like this. So we have an array of roles over here, and this array contains 3 roles, that is admin, author, and the editor. In this case, where we are using an array of roles, we can go ahead and add a role property to our person object, and this role property can be of the type string. But here is a problem with this approach. When you try to use roles array in your application and you try to access a user role, you are bound to forget which role is at which index value in the array. So is the author at index 1 or index 2? So whenever you try to access the roles array, you would be confused whether the author is at index 1 or is it at index 2. And as the number of roles in this array increase, you will always have to refer back to this array in order to check which role is at which index value. Now, JavaScript programmers solve this problem by creating a roles.js file and export constants from that particular file. So let me get rid of this code here. And in order to illustrate the constants approach, what I'm going to do is just besides my index.ts, in the same hierarchy, I'm going to create a new roles.ts file. So we are in our roles.ts file now. In this file, we can export our roles and assign them to constants like so. I will do this for author and editor as well. Since I have all these roles in my roles.ts file now, what I can do is I can import these roles in the file that I need. So let me go back to my index.ts file, and in my index.ts file, what I'm going to do is I'm going to import all the constants that are declared in my roles file. In order to do that, I can use import everything as roles from roles.ts. And this roles file can be imported into any of the TypeScript files where we need to use roles. And in order to use roles anywhere in any TypeScript file where we have imported the roles file, all we have to do is call roles and use the dot notation in order to access all the roles. So here you see my IDE is suggesting three roles, that is editor, admin, and author. So this way, all the roles can remain consistent across all the TypeScript files. And this is how most of the developers use constants for the values that are repetitive in nature and will be used across various JavaScript modules in the same application. But enums in TypeScript solve this problem and offer a better solution. Let me remove this roles import and show you the TypeScript way of solving this problem. So instead of declaring constants in a file, we can use enums in TypeScript. In order to declare an enum, we use an enum keyword like so. This declares an enum called roles, and we can assign different values or different roles that we want this enum to contain. So let's add those three different roles that we want this enum to contain. The first one being admin, followed by author, and third is going to be editor. By default, when you declare an enum, TypeScript assigns them values starting from 0. So admin by default will have a value of 0, author by default will have a value of 1, and editor by default will have a value of 2. So let's try to console log the author and see what value we get. Here you will see that I'm able to access author by using the key author. If we check the value in the console, we get 1. So using an enum, though we are accessing author by the name of the author or the key of the author, we are actually getting a value that is 1. And these values are by default assigned by TypeScript. Now there may be a case where you actually want the literal value of admin, author, and editor as it is with us. So what we can do is we can manually assign these values to each of the properties in the enum. So admin can become admin, author can become author, and editor can have the value of editor. Now when we try to access roles.author, the value that we get in our console is of author. Let me just correct the spellings. That looks good. And since we have our enum now, we can let TypeScript know that the role property in the person object will be of the type of values of enum. This is how we can do it. So instead of saying that role is a string, we say that roles is any value from within the enum roles. Now TypeScript knows that role has to be one of the values from within this enum. So it can either be admin, author, or an editor. Let's try declaring a person object and see this in action. So let me declare a person object here, which will be of the type person. The name of the person can be John, email, password, And now finally, let's assign the role as well. Now, in order to assign the role, I'm going to access the roles enum. As soon as I use the dot notation to access the values within the enum, my editor suggests me 3 possible values that are there within that enum, being admin, editor, and author. I want this person to be an editor, so let's select the editor role. Let's console log our person object and let's see the output. So here we have our person object. It contains the email, the name, the password, as well as the role. And if you see here, instead of having 0, 1, or 2, we have the literal value of the editor. We can take it a step ahead as well, and we can export this enum from our role.js file, which we earlier used for constants. So let me copy this enum and let's go back to our roles.ts file. And instead of exporting all these constants from here, we can paste our roles enum and we can export it. Now I can go back to my index.ts file, and in my index.ts file, I can import roles from my roles.js. Now, since my enum lives in a separate file, I can import the roles throughout my application wherever I need them. Enums are super useful and we would be using them a lot throughout the course and within our sample application that we will be creating while we are practicing. With this, we have the knowledge of all the basic types in TypeScript, and in the next section, we would move on to functions in TypeScript. So I'm going to see you there. Welcome back, guys. In this video, we are going to look at how we can define functions in TypeScript. All methods of defining functions in JavaScript work with TypeScript as well. The only difference being that you can assign the type of parameters of the function as well as the return values that you expect from a function. Let's start by declaring a simple function in TypeScript. Let's declare a function called intro. This function will take in 2 parameters, name and age. In JavaScript world, this would not have been an error, but in TypeScript world, TypeScript is throwing an error. Let's just read the errors and try to understand what TypeScript is trying to tell us. Parameter name implicitly has any type. So TypeScript wants to define the type of value of name as well as of age. To define the type of parameters, we can use the same colon syntax followed by type of the value that we expect. So let me show you how. Here I expect name to be a string, so I can type it like this, and age has to be of a number, so we can type it like this. We can also define what kind of value will this function return in the end. We want our function to return a string in the end, and hence we can let TypeScript know that this function will always return a string as an output. To do so, we can add colon at the end of the parentheses and let TypeScript know the type of value that we expect from this function. So since I expect this function to return a string, I can say string over here. Let's ignore this error for a moment and read the statement over here. So our statement says that we have a function called intro. This intro function will take in 2 parameters, name and age. The name parameter will be of type string, whereas the age parameter will be of type number. And this function in the end will return a string value. Now let's hover over string and see why TypeScript is throwing an error. So TypeScript says a function whose declared type is neither void nor any must return a value. So what TypeScript is telling us is that this function must return a string value as we have typed it over here, but right now it is not returning any value. So let's just go ahead and return a string from this function. Now here I'm returning a simple string. I'm using template literal syntax for JavaScript, and I'm returning the string values saying my name is name, which will pick up the name argument, and age is age, which will pick up the age argument passed in by the user. So instead of using named functions like this, we can also declare the same function as a function expression as well. This is how the syntax would look like in that case. So if I have another function called intro2, which would be a function expression, I can copy the other function from here, and this is how the syntax would look like. Let me correct the spellings here. So intro2 is a function expression, and I have strictly typed the function expression as well. So if you're used to using arrow functions in JavaScript, TypeScript strict typing can be used with arrow functions as well. Let me give you an example of an arrow function, which will use the same function logic that we have applied over here. So let me declare an arrow function. So this arrow function will again take in two parameters, which will be the age and the name. So let me just copy it over here. And it will also return a string. I can use this return statement inside the arrow function. So this is how your arrow function would look like. The arrow function intro3 takes in two parameters, name and age, which will be of type string and number respectively. And this arrow function returns a string, and that it does. These are the basics of declaring a function in TypeScript. Everything remains the same as JavaScript. It's just that you have to define the types of parameters as well as the types of return values that the function is going to return. With this, I think we can move on to the next video. So see you there. Welcome guys. In this video, we're going to look at optional and default parameters for functions in TypeScript. Let's take example of the function that we wrote in our previous video. So I'm going to keep the first intro function and I'm going to remove the rest of the two here. So in our intro function, we know that we take in two parameters, that is name and the age of the person. What we need to understand about these parameters is that these parameters are default parameters and they are mandatory in order to execute this function. So if I try to execute this function without passing in any of the arguments, TypeScript will throw an error. Let me execute this function without passing in the age and only passing in the name of the person. So let's do a console log here. And to our intro function, let's just pass in John and not pass in the age of the person. You can see that TypeScript throws an error, and let's just read through the error. Expected two arguments but got one. Here you can already see the type safety that is being provided by TypeScript. Had it been JavaScript, you would have got this error at the runtime. But in case of TypeScript, you're getting these errors at the time of development itself. So what you're building over here is more concrete than what it would have been in JavaScript. Now, just to illustrate that the error goes away, let me pass in the age. So the moment I pass in the age of the person, the error goes away. Let's see the console if we get the expected result. So if you look at the console, we get the string that we expected. My name is John and the age is 32. Now, what if my function had another parameter called country and I wanted this to be a string? You will see that TypeScript treats all parameters as default and required parameters. Now there is a way of making this parameter as an optional parameter in TypeScript. We have already looked at optional parameters in case of objects and arrays in TypeScript. I want to make the country parameter as an optional parameter. So if you guys want to give it a try, you can pause the video right now and try making it as an optional parameter. The hint here is that we have already seen this in case of arrays and in case of objects. So pause the video right now and give it a try. Were you able to do it? Okay, let's do it together. So in order to make country as an optional parameter, all I need to do is add a question mark here. So the moment I suffix country with a question mark, this becomes an optional parameter and the error goes away. We can refactor our function now to check if the country is being passed as an argument by the user of the function. So I can have a condition over here and I can check if country was passed in by the user. If the country is passed in by the user, we can return a different statement which includes the country as well. Now, if the user passes in an argument of country, we will print the statement, else we will print the statement without the country of the person. Let's do a console log with the country as well. So here you see our function prints two different statements. My name is John and age is 32. My name is John, age is 32, and I live in Canada. Here you see I'm able to invoke the intro function with two arguments as well as with three arguments, and TypeScript does not throw an error. That's because TypeScript understands that the third parameter, that is country, is optional, and if I don't pass it as a third argument while invoking this function, it is okay. So that's how default and optional parameters work in TypeScript. In the next video, we would look at assigning custom types to function parameters as well as custom types to the return types. So see you in the next video. In this video, we're going to set up a new project and gradually we'll build upon and understand various features that are offered by the TypeScript compiler. You can also follow along if you want to, or go through this section of the course whenever you want to set up a new project using the TypeScript compiler. I have my project opened up in WebStorm and this is an empty directory over here. And the first thing that I'm going to do is instantiate an npm project inside this directory. So let's go ahead and do that. I'll open my terminal for that. And in my terminal, I'm going to say npm init. And I'm going to use the y flag. What this y flag does is that it sets all the questions that npm asks while creating a project to yes. If you want to go ahead and answer each of those questions, you can omit the y flag. I'll go ahead with the y flag as of now. The moment I do that, you'll see npm has created a new project inside my empty directory. And if I look at my directory right now, I will have a package.json file within my directory. In the beginning of the course, we installed TypeScript as a global dependency in our system. If you haven't, you can check out the earlier chapter and install TypeScript as a global dependency. You can also check whether TypeScript is installed or not on your system by using the tsc version command inside your terminal. So within my terminal window over here, if I use tsc version, it's going to show me the version of TypeScript that's installed on my system. In my case, you see I have version 4.7.4 installed, which is the latest version of TypeScript at the time of recording of this video. Since we have TypeScript installed, let's go ahead and create a tsconfig file that contains all the TypeScript settings that we might just need. But before we can do that, we need to create a root TypeScript file in our project. So within my directory over here, I will create a root TypeScript file and call it app.ts. So here you will see I have created app.ts within my root file, and now let's create the tsconfig file. In order to create tsconfig file, you can use the tsc init the same way you used npm init. So within my terminal, I'm going to pass the tsc init command. This tsc init command would have created a new tsconfig file within your project. Now let's go ahead and open this tsconfig file. In this module of the course, we're going to go through the various settings that are available within the tsconfig file. We will look at the most important settings that are available and how you can configure your TypeScript to work for your project. One change that I want to make immediately to this file is to go to no emit on errors and uncomment this and set this to true. After this, let's just go to our app.ts file, and within this file, let's console log that it's working. To compile and run this file, I will open my terminal and run this file using the tsc command. So within my terminal, I can do tsc app.ts, and this will compile my TypeScript into JavaScript. Now let's open our file explorer. And over here, you will see that app.js file has been compiled successfully by TypeScript. Let's quickly run our JavaScript file. And you will see it prints it's working in our console. I'll open the JavaScript file as well. And you can see TypeScript has successfully compiled our TypeScript into JavaScript here. With this basic setup up and working, we are further going to improve this setup in the coming videos and understand various features that are offered to us by the TypeScript compiler. So see you in the next video. In our previous video, we initialized a TypeScript project using the tsc init command. Whenever you have a tsconfig.json file in a directory, TypeScript treats this directory as the root of the project. In such a case, we do not have to point to a specific file in order to compile specific TypeScript files to JavaScript. So for example, till now we have been using the tsc command followed by the name of the file like so in order to compile app.ts to app.js file. But with the tsconfig.json file initialized within this tscompiler directory, TypeScript would automatically find all TypeScript files and compile them to JS files automatically for us. Let's have a look at an example. I'm going to create a new TypeScript file and call this app2.typescript within our root project directory and add a simple console log statement to it. So within my project root, I'm going to create a new file and I'm going to call this app2.ts. And within this file, I'm going to have a simple console log statement. Now, since we have our second file in place, we can go to our terminal and run the tsc command. So within my terminal, I'm just going to run my tsc command. Now you will see the moment I run the tsc command, TypeScript compiles the app2 ts file into app2.js file as well. Another thing about the tsc command is that it can be run with a watch flag as well. So within my terminal, I can use tsc command with a -- watch flag. Now what this does is this keeps watching TypeScript files for changes within the root directory. So the moment there is any change in the TypeScript files within our project now, TypeScript is going to ensure that it compiles it automatically to JavaScript files. Let's make a change to this console log statement and see what happens. Now the moment I'm going to save this, you'll see the TypeScript recompiled app2.ts into app2.js. We can open app2.js to ensure that the changes were made. So tsc command in watch mode recompiles every TypeScript file within our root directory as long as you have this watch command running. The watch mode also shows you any TypeScript errors if you encounter one while writing your code. Let's see this with an example. In order to see that, let's open our app2.typescript file and I will declare a constant person over here which will be of the type string. Let's assign it a value of string and let's assign it John. Now in order to produce an error, let's try to reassign this person constant with a number. You'll see TypeScript throws an error. It says cannot assign to person because it's a constant. So any TypeScript compilation error would be available to you in the console if you're running TypeScript compilation in watch mode. Let's get rid of this reassignment. And now TypeScript compiles successfully. You can stop the watch mode compilation by hitting Ctrl+C anytime and TypeScript will go out of watch mode. The TypeScript command line interface has a lot of other commands as well, and you can always look at the help file in order to find out what all commands are available for you to use. In order to open the help file, all you need to do is run tsc --help and this will open all the commands for you. So let me make some space here. And within my terminal, you can see all the commands that are available using the TypeScript CLI. This is a very helpful source of information and you might want to go through all these commands and see what all these commands really do. That's all for the watch mode. We can now move on to the next video. Thanks for watching. From this video onwards, we're going to have a look at various options that are available to us in the tsconfig file, as these options affect how the TypeScript compiler behaves. Let me open the tsconfig.json file. Now you will see that we have a lot of options here, which in most of the cases you don't need to change any which ways. But we would go through the most important ones that you must be aware of. Before I jump to the ones that have been already mentioned in the tsconfig file over here, let me show you two options that exist but have not been mentioned or commented out here. The default tsconfig file that you generate using the tsc init command does not give you the exclude option. It just gives you these compiler options. So there is another option available to you that is called exclude. So exclude is an array that excludes the files that you don't want your TypeScript compiler to compile within your project root. You can pass the path to the file that you want the TypeScript filer to exclude. So for example, if I want to exclude app2.ts file, I can do so like this. Since app2 is in my root directory, I don't need to give the path to the file. It automatically starts from the root directory itself. I'll go ahead and delete the precompiled app2.js file from here. Once that is deleted, we can run the tsc command once again and see if TypeScript compiles app2.ts or not. So let's open my terminal, and in this terminal window, I'm going to run the tsc command. Now you'll see TypeScript did not compile app2.ts into JavaScript file because it was excluded. The setting over here can exclude directories as well and not just files. So for example, I can pass my node_modules directory over here like so, and TypeScript will now not compile any of the files inside the node_modules directory as well. The node_modules directory is excluded by default by TypeScript, so you don't have to exclude it explicitly. Node_modules, as we know, is the directory where all our npm dependencies are installed, and compiling all TypeScript files in node_modules would eat up a lot of resources and is not needed. In worst case scenarios, it might just end up breaking your project, as well as making changes to npm dependencies directly is not suggested. Now, one thing you want to remember about exclude property is that node_modules is only excluded if you do not include the exclude property. So if your tsconfig file looks something like this, where exclude property is not explicitly defined, then node modules is excluded by default. But the moment you include the exclude property, you have to explicitly exclude the node_modules. So over here, I will have to include node_modules inside my exclude property because I have included the exclude property in my config file. And now it's only going to exclude those values that are a part of this array. If you do not include the exclude property, there is no need to include the node modules. But the moment you define the exclude property in tsconfig file, you have to go ahead and mention all the files and folders that you want to exclude from TypeScript compilation. So we can use a wildcard symbol, that is an asterisk, followed by any wildcard path that we want to define. So I can say I want to exclude all files with an asterisk followed by exclude.ts. Now in this case, TypeScript will exclude all the files that have an extension of exclude.ts. The asterisk symbol here acts as a wildcard, which means that any file which has any name but has an extension of .exclude.ts will be excluded from TypeScript compilation. We can go a step further as well and use double asterisk like so. Now what this tells TypeScript is that inside any directory or subdirectory, if you find any file name which has an extension of .exclude.ts, do not compile it. So TypeScript compiler will exclude any nested TypeScript files in any of the subdirectories which have the .exclude.typescript extension if you use this kind of a syntax. Just like the exclude property, we also have include property. So let's go ahead and define an include property here. Include is again an array of values. Now here you can specify if you want to include any specific directories. Once you add this property, TypeScript will include only those files and directories that have been mentioned in the include array. Again, this works very similarly to the exclude property. So in my root directory, I might have an src directory, and I might just want TypeScript to compile this directory only. And in this case, I can include that directory into this array. So let me go ahead and include the src directory into this particular array. Now TypeScript will only compile files that are available within the src directory. You can use wildcards and specific file names within include as well, just as the way we did in the exclude property. Also always remember how TypeScript treats this. It's always include minus exclude, and anything that is not mentioned inside include is not included in the compilation process. Now it turns out that if we want to keep all our files in a single directory like the src directory, then there is a better way to do that, which we will look at in the next video. So see you in the next one. Continuing with our previous video, let's get rid of the include property that we had defined in our tsconfig file over here. And in the exclude property, I'm going to keep the node modules and get rid of the rest of the stuff. Here within the tsconfig file, I want to point your attention to two properties. The first one is the root directory. Let's read what the root directory description has to say. Specify the root folder within your source files. So this property lets you define the source files for the TypeScript project. And if you define this property, TypeScript will look for the TypeScript files in that particular directory and its subdirectories. So I'm going to uncomment this and point this to our src directory. Now TypeScript will only look for TypeScript files within the src directory and compile them. Let me open my file navigator and delete app2.ts file. If you look at the current file structure, we also have the app.js file. So I'm going to get rid of this app.js as well. So we still do not have the src directory, but we are just left with the app.ts file. Just to check whether TypeScript compiles this file or not, let's open our terminal and run the tsc command. You will see TypeScript throws an error over here and says that app.ts file is not within the root directory. So let's go ahead and create the src directory within our project. And let's call this directory src. And I'm going to move my app.ts file into the src directory. Now let's open our terminal once again and run the tsc command. Now you will see app.ts successfully compiles to app.js. So TypeScript correctly identifies the root directory. This is a good practice for large projects because you want to have all your source files within a specific directory. The second property that I want you to look at is the out directory, right here. This property lets you define an output directory for all the JavaScript files. So if I go to the root of my project and create a new directory over here and call this directory as dist, I can then activate the out directory and tell TypeScript to compile all JavaScript files in the dist directory. Let's go back to our src file and delete app.js over here, which was compiled by TypeScript. And open our terminal once again and run the tsc command. You will see that app.ts does not get compiled to app.js within the src directory now. But if I open the dist directory, you will see that app.js exists over here. This also follows any directory structure that you might have in our src directory. So if I create a new directory called functions within my src directory and add a new file to this called username.ts and just add a simple console log statement, which just prints the name John to the console. Now if we open our terminal and run the compiler once again using the tsc command, we will see that within the dist directory, a new functions directory is created, and within the functions directory, we get username.js. So TypeScript here follows the hierarchy that we follow in the src directory. From now on in our project, we will follow the src and the dist input and output structure for TypeScript compilation. In the next video, we will have a look at the target property of our TypeScript compiler. See you in the next one. Welcome back. In this video, we would be looking at the target and lib properties of the tsconfig file. We are back in our tsconfig file. Let's start by understanding the target property. The target property defines the version of JavaScript to which our TypeScript will be compiled. As you can see, I'm using ES 2016 version at the time of recording of this course. The version that you use highly depends on how you are using your TypeScript. This means factoring in questions such as, will the TypeScript run in the browser once it is compiled? Are you using ReactJS with TypeScript? Or is your project a server-side app using Node? All these factors impact the target version of JavaScript to which you would want to compile your TypeScript files to. So let's open the TypeScript official documentation to have a look at the various values that are supported by the target property. You can see TypeScript supports all versions as low as ES3 and high as ES Next. How would you decide which version of TypeScript you would want to use? Well, it turns out that most of the times you would not have to figure it out by yourself, as most of the boilerplates like Create React App, Next.js installer, etc. come with their own settings and have the required tsconfig files within them. But just in case you need to decide for yourself and need to understand which boilerplate uses which version of JavaScript, then you can refer to this particular GitHub repository. This repository is called tsconfig basis, and over here in this repository you can scroll through various technologies that you would want to work with and there is a link to the tsconfig file used by each of those technologies. So you have the most common recommendations: create React app, Cypress, Dino, and whatnot. To have a look at tsconfig file of each of these technologies, you can just click on this particular tsconfig.json link and it will show you the required TS configuration. So for create React app, you would need to have following libraries enabled, and you will also need to set the target to ES5 because React runs in the browser and that's where you would at least need ES5. There are many ES6 features which many browsers do not support, and probably that's the reason why create React app uses ES5. So you can see there are recommendations for many technologies, and it's a great starting point in case you want to have your own custom configuration file. I hope this is clear. Let's move on to the next video where we would understand the lib property.